Hello, everyone. I see the chat is very busy with folks. That's really awesome. Happy Thanksgiving to everybody. And yeah, we're just going to jump into it here. So, as you already know, this is how to inspect fireplaces, stoves, and chimneys. There's a really good course on InterNACHI we'll include a link to if you just want to brush up after the fact. But we're going to cover everything here today. And so the goal of the inspection of the fireplaces, stoves, or chimneys is to provide observations that may lead to the decrease of hazardous conditions associated with fireplaces and chimneys, which are pretty substantial if you guys aren't already familiar. And the number one goal is always safety. So this is a huge component of the safety aspect of any inspection. If there is a fireplace, a stove, or a chimney, it's always a major source of concern. So, if the inspection reveals that the existing chimney is not safe for the intended application, it must be repaired, rebuilt, lined, relined, or replaced with a vent or chimney to conform to building standards. So, let's jump in here on our next slide. Whoops. Here we go. So, the scope of the inspection is limited to readily accessible and visible portions of the fireplace and chimney, which is true for most of what we do anyway. Most of what we do, if not all of what we do, is visual only in terms of requirement. The inspection is not all inclusive or technically exhaustive, which again is pretty much true of our entire inspection. The inspection involves a visual only examination of the readily accessible portions of the chimney exterior, interior, accessible portions of the appliance, and the chimney connection. The inspector, who is you, should look at the general structure of the chimney and any connections to appliances, stoves, and heating systems. The inspector should also look for improper installation, obstructions, and combustible deposits, which we'll talk a good bit about. The inspector should advise his or her client that all fireplaces, fuel-burning stoves, and chimneys should be inspected by a certified chimney sweep prior to their first use and not less than annually, which, if you ask me later, I'll tell you why my dad knows that firsthand. Standards of practice. The inspector shall inspect readily accessible and visible portions of the fireplaces and chimneys, lintels above the fireplace openings, damper doors by opening and closing them if readily accessible and manual operable, and clean out doors and frames. The inspector shall describe the type of fireplace. The inspector shall report as in need of correction, evidence of joint separation, damage or deterioration of the hearth extensions or chambers, manually operated dampers that did not open and close, the lack of a smoke detector in the same room as the fireplace, the lack of a carbon monoxide detector in the same room as the fireplace, and cleanouts not made of metal, precast cement, or other non-combustible material. The inspector is not required. Now, it says not required to. Doesn't mean you cannot. You should kind of consult with whoever gives you insurance as to whether or not you want to do any of these things, but you're not required to inspect the flue or vent system, inspect the interior of chimneys or flues, fire doors or screens, seals or gaskets or mantles. Determine the need for a chimney sweep, operate gas fireplace inserts, light pilot flames, determine the appropriateness of any installation, inspect automatic fuel-fed devices, inspect combustion and or makeup air devices, inspect heat distribution assists, whether gravity controlled or fan assisted, ignite or extinguish fires. I would love if that would go without saying, but we'll read number 10 again. Ignite or extinguish fires. You're not required to do that. Determine the adequacy of drafts or draft characteristics, move fireplace inserts, stoves, or firebox contents, perform a smoke test, dismantle or remove any component, perform a National Fire Protection Association style inspection, or perform a Phase 1 fireplace and chimney inspection. So again, you're not required to do any of these things. Inspecting the flue or vent system, inspecting the interior of chimneys or flues, if you can do it easily, then someone else can probably do it easily. So if you miss something, just be aware that if a new home buyer can see something pretty readily, just because you're not required to do it doesn't mean they won't do it, in which case they may call you on it. But that kind of goes with a lot of things that we do that are not required to do. The standards of practice are sort of like building code. They're the minimum applicable standard. So if you choose to exceed them, again, check with your state and your local authority having jurisdiction and whatever the standards of practice are for your state licensure. But Again, it's a minimum requirement. So let's talk about chimneys. So a chimney is a vertical shaft through which smoke and gases from fuel burning heating systems, stoves, appliances, and fireplaces exhaust. The chimney may be built of masonry or metal pipe materials. The flue liner, chimney inner wall, or inner vent wall must be continuous and free of cracks, gaps, perforations, and other damage and deterioration that could allow the escape of combustion products, including gases, moisture, and creosote. Creosote's kind of the big one. So multiple solid fuel venting is prohibited. So a solid fuel burning fireplace, stove, or heating system cannot connect to a chimney venting another fireplace, stove, or heating system. It's prohibited. And if you want, you can refer to the 2021 IRC M1801.12. And I'll have a link at the end for if you don't know where to find the digital codes for the IRC, I'll show you. But a solid fuel burning appliance or fireplace must not connect to a chimney that serves to vent another appliance. Each solid fuel burning appliance or fireplace must have its own dedicated independent chimney or vent. That's really important, and that's something that we can usually readily see if two things are tapping into each other. It's something that you've got to call out because it's a huge safety issue. Here's why. Solid fuel burning appliances produce creosote on the interior flue liners of chimney stacks. So creosote's highly combustible. It builds up kind of in three phases. And again, we'll talk about that later, and I'll show you guys examples of the three different levels of creosote buildup. But no matter what the buildup, it is highly combustible. And if there's a chimney fire, other connections to the chimney could allow the fire to travel out of the chimney and into the home. Chimney passageways can become partially blocked by creosote formation. That's usually what we consider a level 3 creosote buildup, and that can force vent gases from another appliance to exhaust back into the home. So an appliance must not be connected to a chimney flue serving as a separate appliance designed to burn solid fuel. A solid fuel burning appliance or fireplace must be connected to a dedicated independent chimney or a dedicated independent flue inside a multiple flue chimney construction. So again, some chimney constructions have multiple flues inside them. That's okay if there's more than one flue, but each flue has to be dedicated for that appliance. Excuse me. Solid fuel burning appliances and fireplaces cannot share a common chimney or flueway. And again, we're hammering this because it's such a safety concern to have one flue tapping into another flue. Now, combination dual fuel, gas or oil, and solid fuel burning appliances are designed to be connected to a single chimney passageway. Such dual fuel appliances must be listed, labeled, and installed according with the manufacturer's instructions. And again, that's the guidelines there. Refer back to the 2021 IRC, and we'll get a link to that later. Gas and solid combo appliances. A combination gas and solid fuel burning appliance may be permitted to be connected to the same single chimney flue, but there has to be a manual reset device to shut off gas to the main burner in the event of a sustained backdraft or flue gas spillage. Further, the chimney flue must be sized to properly vent the appliance. The dual fuel appliance is not a very common one, so it's not something you'll probably see, but it is able to be connected to a single chimney passageway. Connectors, as you can see here, those are used to connect fireplaces, stoves, and heating systems to a vertical chimney, except where the chimney or vent is directly attached. So connectors for all oil and solid fuel burning appliances must be made of factory-built chimney material, type L vent material, or single-walled metal pipe that is resistant to corrosion and heat, for obvious reasons. The pipe thickness should be a certain minimum of galvanized steel. For pipes 6 inches or smaller, the minimum is 26 gauge galvanized sheet metal. Connectors must be accessible or removable for inspection and cleaning. Unused openings in chimneys and vents should be closed. At a masonry chimney flue, the connector vent pipe must connect at a point at least 12 inches above the lowest portion of the interior of the chimney flue. Some building codes provide only for 8 inches. Connector vent pipes should be installed in accordance with the manufacturer's installation instructions. As far as length and slope are concerned, stoves and chimney heating systems shall be located as close as is practical to the chimney. Connectors must be as short and straight as possible. The general rule of thumb for the maximum length of an uninsulated connector pipe to a natural draft chimney is 10 feet. According to the 2018 International Residential Code, Section M1803.3.2 states that the horizontal run of an uninsulated connector pipe to a natural draft chimney should not exceed 75% the height of the chimney above the connector. The horizontal run of a listed and labeled connector pipe to a natural draft chimney should not exceed 100% of the chimney height above the connector. Connectors should be sloped at least a quarter inch of rise per foot of run, or 12 inches of run. As far as fastening, connector joints should be fastened with sheet metal screws or rivets. Passing through a chimney connector pipe or vent connector pipe should not pass through any floor or ceiling. It should not pass through a wall either unless it's listed and labeled for a wall pass-through. A single wall metal pipe used as a vent connector passing through a wall, ceiling, or floor must be guarded by a ventilated, non-combustible metal thimble and must contain a minimum clearance of 6 inches between the thimble and any combustibles. A non-combustible thimble must be used where a single wall metal pipe passes through a roof constructed of combustible material. It would be uncommon to find a single wall metal pipe passing through a ceiling, wall, floor, or roof. For unlisted single wall chimneys and vent connectors, a single wall metal pipe used as a vent connector must maintain a minimum clearance of 18 inches between the metal pipe and any combustibles. The size of a connector pipe should not be smaller than the flue collar of the appliance. So we don't want bottlenecking. We can't have any reduction in the size of that pipe as it travels. We'll talk about the inlet now. So, inlets to masonry chimneys must enter from the side. Inlets must have a thimble made of fire clay, rigid refractory material, or metal that will prevent the connector from pulling out of the inlet or from extended beyond the wall of the liner. And you can see this wonderful diagram here. If the vent connector extends too far into the chimney, it might prevent proper venting. As you can kind of see visually there, if you push it any further back, the wall is going to obstruct part of that venting. Sorry. Now, the 3-2-10 rule for masonry chimneys, you would have to measure this from the surface of the roof probably, but you kind of develop an eye for it if it seems like it's not right. But they should be high enough, chimneys should be high enough to prevent downdrafts caused by the wind. The 3-2-10 rule for masonry chimney states that the masonry chimney should extend at least 3 feet above the highest point where the chimney passes through the roof and 2 feet above any portion of a building that's within a 10-foot distance horizontally. Now, hopefully that makes sense but with the diagram you're looking at. But again, 3 feet above the highest point where the chimney passes through the roof, 2 feet above any portion of the building that's within a 10-foot distance horizontally. House framing components should be at least 2 inches away from the chimney wall. Open spaces between the chimney wall and the combustible materials should be sealed and insulated with non-combustible material, like fire block. And now they have some foam that you can use. A masonry chimney footing. A masonry chimney has its own footing, and it's built in such a way that the chimney provides no support to or receives support from the house structure. The chimney footer may be connected with the house foundation and footing. Footings for masonry chimneys must be made of concrete or solid masonry at least 1 foot thick, and they should extend at least 6 inches beyond the face of the fireplace or the foundation wall on all sides. Footings for masonry fireplaces must extend below the frost line. They must be installed on natural, undisturbed earth or engineered fill below the frost depth. In climate areas not subject to freezing, the footing should be installed at least 1 foot below the finished grade. The chimney lining, as you can see here, it's required for masonry chimneys. All masonry chimneys have to be lined. The chimney lining must be appropriate for the type of fireplace, stove, appliance, or heating system connected to it. The walls of the masonry chimney having a clay interior flue should be at least 4 inches thick, considering a standard brick is 3 5/8 inches wide. The minimum standard thickness for a clay flue liner is 5/8 of an inch thick. The 2018 International Residential Code R606.3.1 states that the bed and head mortar joints should be 3/8 of an inch thick. In the United States, the common dimensions of a masonry brick are 3 5/8 inches wide, 2 1/4 inches high, and 7 5/8 inches long. The actual dimension is the measurement of the brick. The nominal dimension is the measurement of the brick and one mortar joint's thickness. So the nominal thickness of the brick wall at the masonry chimney must be at least 4 inches, 3 5/8 inches wide for the brick, plus 3/8 of an inch for the mortar joint. In the inspection image above, or that you're looking at, taken of a brick chimney stack for fuel-fired heating systems, the blue arrows indicate the nominal thickness of the chimney wall. The size of the chimney depends on the number and size of the flues. The flue for a heating system or fireplace should have enough cross-sectional area and height to create adequate draft. Masonry chimneys can have a clay, ceramic, cast-in-place, or metal conduit flue lining. Modern standards require liners to be installed in all masonry chimneys. Unlined chimneys are not safe. A chimney without a flue lining is considered a material defect and should be reported. And again, if you're not sure why, cracks and things like that propagate through a lot of masonry materials, and you can get some serious issues if you do not have a flue liner. So if you're seeing a chimney without a flue liner, that is an immediate big red flag. It's a material defect, not deflect. The purpose of the flue is to contain the combustion products, direct them to the exterior, and protect the masonry chimney walls from heat and corrosion. A masonry chimney without a flue liner must be professionally inspected and corrected by a certified chimney contractor who will make repairs or replacements so that it meets modern safety standards. Clay tiles are the most common type of masonry chimney liner. Clay tile flue linings can be square, rectangular, or circular. The clay lining in the inspection image shown is square and serving an oil-fired forced air furnace in the basement. The picture on the right, obviously. The clay lining in the inspection image on the left is obviously circular and also clay. They come in all different sizes, diameters, and cross-sectional pieces. The general rule is that a single flue should be used only for one heating system, like we said before. You may find the vent from a gas-fired furnace and gas-fired water tank connected to one flue. The clay flue lining should extend above the brick course or masonry cap a minimum of 4 inches. The masonry cap must be sloped in order to direct water away from the flue and off the chimney top. Metal chimney flue liners are usually made of stainless steel or aluminum. They are used to upgrade and repair existing masonry chimneys. Stainless steel is suitable for wood burning, gas, or oil applications. Aluminum is an inexpensive alternative for certain medium efficiency gas heating systems. The cast-in-place lining. A cast-in-place chimney flue liner is made of a lightweight cement-like product installed inside the chimney. The cast-in-place lining is a smooth, seamless stack. It can help correct the structural integrity of an old chimney. Cast-in-place liners are suitable for all fuel types. It's a common mistake to apply the height requirements for chimney terminations, the 3-2-10 rule, to fuel vents, which can cause vents to extend above roofs much higher than needed. So in most cases, for example, vent pipes terminating above roofs having a slope of 612 need to be only 1 foot high. So sometimes people apply that 3-2-10 rule to a type B vent, and that's not applicable. It's supposed to be for the masonry chimney only. So the type of venting materials is dependent upon the operating characteristics of the appliance being vented. Appliance can be characterized with respect to positive or negative pressure within the venting systems, and whether or not the appliance generates gases that condense in the venting system. Regardless, all appliances must be connected to venting systems. The venting system must never extend into or pass through any fabricated air duct or furnace plenum. It must convey an adequate positive flow of flue or vent gases directly to the outdoors. There's several types of venting systems that can be used, including plastic piping, special gas vents designed by the manufacturer, and masonry, metal, and factory-built chimneys. Gas vents that are 12 inches or less in size and located at least 8 feet from a vertical wall or a similar structure should terminate above the roof in accordance with the gas vent terminations table that you can see on the right. Gas vents that are, I just said that. These requirements indicate that a greater vent height above the roof is needed as the roof pitch approaches being a vertical surface. The greater the roof slope, the greater the effect of the wind hitting the roof surface. Gas vents that are greater than 12 inches in size or that are located less than 8 feet from a vertical wall or similar structure should terminate at least 2 feet from the highest point where they pass through the roof and not less than 2 feet above any portion of a dwelling within 10 feet horizontally. There are other requirements for direct vented fireplaces, appliances with integral vents, and appliances using mechanical draft fans. So we just talked about type B vents a second ago. A type B or type L gas vent must terminate at least 5 feet in vertical height above the highest connected appliance's draft hood or flue collar. A type BW gas vent must terminate at least 12 feet in vertical height above the bottom of the wall furnace. Gas vents shall extend through the roof flashing, roof jack, or thimble and terminate with a listed cap or assembly. Type B vents are suitable only for listed draft hood equipped gas fired appliances, including most domestic heating and hot water systems. They may not be used with any of the following appliances. They're not able to be used with wood burning appliances like fireplaces and wood burning stoves, incinerators, oil fired equipment, coal fired equipment, any appliance that burns anything other than LP gas or natural gas, or any appliance that produces flue gases that exceed 480 degrees Fahrenheit or 249 Celsius, if there's anybody here using that system. Type B vents must be equipped with their own special chimney caps. If the cap is damaged or lost, it should not be substituted with something not recommended by the manufacturer. If you've got a good eye, you can kind of catch this sometimes when you're looking at it. If that cap got knocked off somehow and they just picked up whatever they had or fabricated something, that's not allowed. The clearance required from combustible materials is printed on the flue's exterior metal surface and is generally 1 or 2 inches. Type L vents are designed for venting approved oil-fired and natural gas appliances that produce draft hood flue gases that do not exceed a temperature of 570 degrees Fahrenheit or 926 degrees Fahrenheit for 10 minutes in an overfire situation. The minimum clearance from combustible materials is generally 3 inches. Type L vents should not be used to vent coal or wood-fired appliances. It might be difficult to tell the difference between type L and type B vents because they're made from similar components, but the vent type should be clearly printed on the vent itself. Both are double-walled, although type L vents generally have a stainless steel inner wall, while type B vents do not. Regardless of the vent type, InterNACHI inspectors may check for the following defects: deterioration of the outer wall, which is likely caused by failure of the inner metal lining; violation of roof clearance requirements. All metal vents must terminate at least 2 feet above the roof surface and at least 2 feet above any portion of the building within 10 feet horizontally. You can check for missing components such as a chimney cap. You may check for fire stops not installed at either the top or bottom side of the joist where the vent passes through the floors or the roof. The fire stop should allow a fire resistance rating equal or greater than the floor or roof assemblies through which the vent passes. You can check for blocked bird screens, often caused by freezing moisture in cooler climates. Crucial joists, rafters, or other load-bearing structural members that have been cut to allow for the vent to pass. This is, I hate to say common, but it's not uncommon. Plumbing and electrical lines should also not be disturbed by the vent, and whether the vent is too high or too low. Manufacturers may set minimum and maximum height requirements for the whole vent assembly, such as the airjet type L vent, whose minimum height is 6 feet and the maximum height is 30 feet. Inspectors may recommend that extra corrosion resistance for vents may be provided by a stainless steel cap, stainless steel jacketed pipe sections, or stainless steel or aluminum flashings and storm collars. They may also recommend that clients use commercially available combustion enhancing acid neutralizing fuel additives to prevent damage caused to vents by sulfuric acid. In summary, type B and type L vents are designed to vent gases from specific types of appliances and under certain conditions. If you look quick at table 1, you're looking at the different roof slopes and the minimum height that B vent termination should be. So if you can see, if it's less than 8 feet from a vertical wall or gable end, the vent must terminate 2 feet higher than any portion of the building within 10 feet. And it says pretty much the same thing on the bottom, but that's not a bad opportunity for a screenshot there. Sorry, just gotta update my PDF here 1 second. All right. Next slide. Corbelling and offsets. So masonry chimneys are sometimes corbelled, meaning several successive courses are extended outward. Sometimes corbelling is observed from the unfinished attic space, like you can see in that photo, above the roof surface, or on the side of the house. Corbelling is usually observed in a location of the chimney just before the chimney stack rises above the roof. It could also be at the top of the stack, as in the inspection the inspection photo shown. Corbelling is the projection of Corbelling is the projection of masonry in small increments for each course of masonry. The chimney should not be corbelled more than 1/2 of its wall thickness from the wall or foundation. A single course is not permitted to project more than 1/2 of the individual unit's height or more than 1/3 of the individual unit's depth. Corbelling can be used to change the direction of a masonry chimney, as shown in the inspection image. In this unfinished attic, the corbelling creates an offset of the brick chimney stack. The brickwork transitions as it extends through the attic space. The corbelling should have a maximum offset so that the center line of the upper flue doesn't fall beyond the center of the lower flue wall. The cross-sectional area of the flue should not be reduced through the offset. These factors are not readily visible or discernible during a visual-only home inspection. Remember that a home inspection is not a certified chimney inspection, and it does not include the interior flue liner. So again, these are good things to know, not necessarily things that you're going to be able to observe during an inspection, but as is the case with a lot of InterNACHI training, we're going to give you more information than you really need, and that gives you a great foundation for visual-only inspections in the field. So if the masonry chimney is built with a clay flue liner surrounded by one width of masonry, the maximum offset should be such that the center line of the flue above the offset does not extend beyond the center of the chimney wall below the offset. There are limitations on chimney offsets that provide a gradual transition so that a critical stress concentration at the bottom of the offset is prevented. The maximum offset of the center line of the flue the maximum offset of the center line of the flue to the center line of the wall of the chimney below maintains structural stability for vertical loads. Masonry chimneys shall not be corbelled outward more than 1/2 of the chimney's wall thickness from a wall or foundation. The outward projection of a single course shall not exceed 1/2 of the unit's height or 1/3 of the unit's bed depth, or whichever is less. Corbelling on a chimney stack occurs when each successive course of bricks in the chimney is stepped either inward or outward. Corbelling is commonly used to create a wider, lower base that distributes weight and transitions from the narrower section of the chimney near the roof line to the wider base in the areas below. Key inspection points. Structural transitioning. The corbelled section is typically where the chimney stack transitions. The corbelled section is typically where the chimney stack transitions to a different size as it passes from the living space through the attic. Look for any irregularities in the brick stepping pattern. So again, it should look pretty uniform. This is like most things in home inspections. You don't necessarily need to measure things with a tape and things like that. You can for the picture's sake, but the reality is you're looking for patterns and anomalies to those patterns. So if it looks like it's stepping up correctly, it probably is, and you can measure it to confirm. But if you see something off, something doesn't look quite right, it's good for further investigation. So another key inspection point is the mortar condition. Inspect the mortar joints between the corbelled bricks. Mortar should be intact and not crumbling, as weakened mortar can lead to shifting bricks and instability in the chimney. And that's not just true for corbelling, that's true for any masonry chimney, any brick or masonry chimney. If there's mortar joints, you really need to look for them to see if they're intact and not crumbling. The brick alignment is another key inspection point. Each brick in the corbelling should be correctly aligned with the one below it, only extending slightly outward. Excessive extension or misalignment may suggest poor construction or past repairs. And that's a big one too. Past repairs, like I said, we're looking for patterns and anomalies to that pattern. So again, if you look pretty much in any of these photos we're showing, you can see that the bricks look all pretty uniform. If something looks newer or different than the others, then may be appropriate to ask about repairs if the owner knows about it, or just note it in your report as that there's a sign that something's been changed. Signs of moisture. Since the attic is often an unconditioned space, look for signs of water damage around the corbelled area, such as efflorescence, which are white salt deposits, spalling, flaking of the face of the brick, or discolored mortar. So, whenever we're looking at masonry, these are some of the things that we're looking for, whether it's in a basement, whether it's on a chimney, pretty much any masonry that's you're looking from the inside. If there's efflorescence on the surface, you're going to want to call it out in your report. And those are those white salt deposits. We don't have a picture of it right here. And then spalling of the brick really just indicates it's getting very old and it's not in good condition. Another thing you need to look for is the clearances. Ensure that there's adequate clearance between the corbelled chimney and any combustible materials in the attic. Building codes typically require a 2-inch clearance from wood framing or insulation. So 2 inches is a good rule of thumb. Usually that's a minimum. So, a local jurisdiction may require more than that, but usually 2 inches is a good rule of thumb. Why it's important. Corbelling and offsets can affect the structural integrity of the masonry chimney as it passes through different parts of the home. If there's a failure in the corbelled brickwork or mortar, it can lead to chimney collapse or fire hazards if cracks allow gases or embers to escape into the attic space. And again, this isn't just true of corbelled chimneys, it's true of all chimneys. Corbelled chimneys just happen to be, because they're transitioning from that wider area into a thinner area and they're offset. If there's weaknesses in the mortar, if you see cracks, and a crack in the mortar may not just be because of age, it may be because of some kind of a load path taking advantage of that mortar. And if it's not repaired, it could lead to chimney collapse, right? By inspecting the corbelling and offsets from the unfinished attic, you can assess the long-term durability and safety of the chimney, which is crucial for preventing fires and crucial for preventing damage and fire risks. So again, you're not required to speak to the longevity of any particular material, but if you're starting to see some failures, if you're starting to see some cracks in the mortar, if you're starting to see some spalling of the brick, it's important to call it out, because that will, call in an expert who may be able to speak more specifically to the need for a repair. Our job is just to see if there's anything that looks not quite right and then call an expert in. Chimney flashing and crickets. So your chimney flashing should be installed wherever the stack meets the roof to prevent water penetration. That is pretty much true of any penetration in a roof. It just happens to be that chimneys are usually some of the biggest penetrations, so the flashing is huge. And you can't see the flashing here. If you get up real close when you're on a roof, if you get on roofs, most places you're not required to. But if you see something like really that stucco may be a little too close to those shingles in that image right there, but you want to get a little bit close to that transition and see if you can see any of that shiny metal. The picture on the right there shows that step flashing will be underneath those shingles. It looks like there's no flashing in that picture. So these are things where an overview is great, and then you come in and take a close-up and see if you can see it. If you can't see it, that doesn't necessarily mean it's not there. So you may just have to investigate a little further as to why maybe you're not seeing it. Again, with that stucco chimney on the shingle in that picture on the left, it may not be that the flashing is not there. It may just be that the stucco, really any type of material that can wick moisture from the surface of a roof, should be at least 1.75 inches above the roof. Sometimes 2 inches. Hardy siding should be about 2 inches. So again, if it's installed correctly, you should be able to see that step flashing and take a picture of it and confirm that it's there. If it's installed not properly, which is, in some cases more often the case, you're just going to have to get a little bit closer and investigate. And if you can't see, then you may just have to disclaim it. Rather than saying there was no flashing here, you may just want to say, I couldn't see the flashing there. So the flashing should be installed where the chimney stack meets the roof. Flashing is typically made from corrosion-resistant metal, such as copper. It's probably less commonly copper than it is to be aluminum. Counter flashing is installed in the mortar joints and then folded downward to cover the step or base flashing. If the chimney has dimensional parallel has a dimensional parallel to the ridge line greater than 30 inches and does not intersect a ridge line, a chimney cricket must be provided. And they at least did that correctly in that photo on the left. And again, you can usually tell by eye, but if you're already up there, just pull your tape measure out, check if it's bigger than 30 inches. It's got to have a cricket on it. And I've seen more, like very often, where it doesn't happen and then it ends up leaking because that thing just becomes a big water dam. And whatever flashing you have there is basically just a small little hump to jump over for the water to get inside. Once that water starts building up back there, then it also will build up, sticks, leaves, all kinds of debris behind that chimney, and that becomes a sponge for water, and it's all going to try to take advantage of the shingles in that area or whatever roof covering you have. So the height of the cricket depends on the slope of the roof. The lower the slope, the shorter the cricket height. Sorry, I was just taking a peek at the chat real quick. All right, so the chimney cap, some people call it a crown, some people call it a chimney wash. Either way, all masonry chimneys should have a concrete, metal, or stone cap. Take a look at the illustrations to see the chimney cap identified. On the illustration, the chimney cap is made of concrete. It covers the top of the chimney wall and covers the space between the chimney wall and the clay tile flue liner. The illustration shows a chimney cap covering the top opening between the chimney walls and the flue liner. The masonry chimney cap, also referred to as the crown or the wash or even the splay, is the top element of a masonry chimney. It covers and seals the top of the chimney from the flue liner to the chimney edge, the chimney exterior walls. It's often referred to as a crown because of its form and function. The masonry chimney cap should provide a downward slope that will direct water from the flue to the edge of the cap. The crowned cap should be formed so as to shed water. So there should be some slope from the center towards the outer walls to carry the water away from the middle of the chimney. Most masonry chimneys are built with an inadequate crown constructed from a common mortar mix. The crown must be designed for years of weather abuse without cracking, chipping, or deteriorating. And this is a super, super common thing for any of you guys who actually do get on the roofs during your inspections. These caps, these crowns, they're cracked all the time. And you can see on that photo on the left, there's some repairs that have been made to those cracks. On the right, there's a crack starting to propagate through. And it's just a super, super common defect. Really easy to see, really easy to call out. So the crown must be designed for years of weather abuse, like we said. A proper chimney crown should be constructed of a Portland cement-based mixture and cast or formed so it provides an overhang projecting beyond all sides of the chimney by a minimum of 2 inches. A flue liner tile of masonry chimney should also project above the crown a minimum of 4 inches. So, and you can see that it looks to be the case in both of those instances. A metal rain cap and spark arrestor may be installed on a masonry chimney. The inspection image before the one above does not, what does it say? Before the one above does not have either installed. Okay, so the first one you're seeing, that doesn't have the spark arrestor. The arrestor screen should be made of heat and corrosion resistant material such as galvanized steel, 19 gauge is good, or stainless steel, which needs to be 24 gauge or better. The screen openings should be sized to allow the passage of a sphere with a diameter between 3/8 of an inch and 1/2 of an inch. So that's pretty small.
What is a cap? A chimney cap on a masonry chimney, and what's a spark arrestor and what's a rain cap. So on masonry chimneys, that's the important part. A masonry chimney must have a concrete, metal, or stone cap and a drip edge and a caulked bond, which is a break, around any flue liners so that they're not together or stuck together, right? And the cap is going to be sloped away to shed water. That's different from a spark arrestor, and that's different from a rain cap. And the interesting thing about rain caps is they're installed at a prescribed distance above the chimney flue termination to prevent backdrafting or draft problems. So the rain cap is kind of like the umbrella that you hold over your head, right? And it's just to divert rainwater away from the interior flue liner, but it's got to be lifted up at a certain point, 4 times the size of the flue, so it can vent, right? So A rain cap is different from a spark arrestor, which arrests the sparks from a fireplace flue. We wouldn't want things coming out of the fireplace chimney. And it's different from a chimney cap. So masonry chimney cap is different from a spark arrestor, and it's different from a rain cap. And to get a good idea of those things, you can go to any NACHI.org page and open up our free online chimney course. And that's under Get Started, go to Education and search for chimney and how to inspect fireplaces, stoves, and chimney course. And you log into the chimney course, and this is the cap. This is the chimney cap on a masonry chimney. It goes from the interior flue to the far edge, outer edge of the chimney stack. Here's the chimney cap here. Here's the chimney cap with the drip edge, right? And here's that bond break, right? In between the flue liner and the chimney cap. And my hand is resting on the chimney cap. It's not resting on the spark arrestor. It's not resting on the rain cap. This is a chimney cap. And sometimes it's called a crown or a wash. And that is a rain cap and a spark arrestor. All right. So those are the differences in terminologies. You can all get that from InterNACHI's online course about how to inspect fireplaces, stoves, and chimneys. And it's also in the code as well. And that's, I'm referring to the 2021 IRC code at section R 1003.9.1.
Okay. So I think Ben did a pretty good job of explaining it. Again, if you want to avoid the term cap, fair enough to just call it a chimney crown or a chimney wash so that it's not confused with a rain cap. And then a spark arrestor hopefully isn't confused with either, but it is that sort of metal mesh screen looking thing that stops anything flammable from getting out of the chimney flue into the surrounding area. So let's talk about the fireplace, and we're going to talk about the hearth and the lintel. So the hearth is made up of two parts. Most people only think of it as that part that extends out the front, but it's actually the front and the back. So the front hearth is the part most people know about, which is located in the front of the fireplace combustion chamber, and the back hearth is located within the fireplace combustion chamber. So the back hearth is made up of fire brick that can withstand heat from the fire. The hearth is completely supported by the fireplace structure. It's built initially with framing components that make up a temporary support structure. Then concrete is poured, reinforcement is installed in the pour, and the temporary support is removed after the concrete is completely cured. No combustible materials should remain in place under the hearth or hearth extension after construction. So once the home's built, you probably won't be able to see this, but depending on if you're doing different phases of construction inspections, you may be able to identify that and put it in your notes as something. If they still have those supports in place, tell them to get them out of there. The inspector should inspect for hearths that are made of concrete or masonry. The inspector should also inspect for hearths that have a thickness of less than 4 inches and call that out. The lintel is located over the fireplace opening and supports the masonry above. It must be made of non-combustible material, and the minimum bearing length of each end of the lintel is 4 inches. Okay, that's the minimum bearing length. Longer is fine. And you might be familiar with lintels in other applications, like if the exterior cladding is masonry, the doors, pretty much any opening is going to have a lintel to support that brick above. The size of the fireplace is based on the size of the room. Okay, we're talking about the firebox, the side, and the rear walls. Most fireplaces are sized large enough to receive a 2-foot long piece of firewood. With a few design exceptions, the firebox of a concrete or masonry fireplace must be at least 20 inches deep. The space inside the masonry fireplace is the combustion chamber or firebox. The firebox walls, which extend upward to the damper, could be made of solid masonry units, stone, and concrete. If there's a lining of fire brick or other approved lining material inside the firebox, it should be at least 2 inches thick. Behind the lining should be the back and side walls made of solid masonry. The total thickness should be about 8 inches, including the back wall and side walls and the lining. The width of the mortar joints of the fire brick lining should not exceed 1/4 of an inch. Bigger mortar joints, it's not as heat resistant of a material. It's not as sturdy of a material. It's going to start to crack and leach gases and smoke out into that other area. So the mortar is a special type of clay mortar used just for fireplace combustion chambers that can withstand excessive heat. A medium duty refractory mortar. But again, it can withstand excessive heat. That's what it's made for. But the lining should not exceed a quarter of an inch. If there's no lining inside the firebox, then the back and side walls should be at least 10 inches thick of solid masonry. Remember that this measurement is for masonry fireplaces and not factory built fireplaces, which is going to be covered in the next section. The firebox walls are slanted to reflect heat energy into the room. The angle of the walls is referred to as the splay of the walls, and splay slope is usually 5 inches per foot. The sloped walls help direct smoke into the throat of the fireplace and also, again, reflect that energy into the room. The photo above, or the photo shown, shows where the mortar joints of the fire brick are very large and there's a lot of cracking of the lining, particularly at the joints. The throat and the damper. The throat of the fireplace is located above the combustion chamber. It controls the efficiency of the fireplace. The rising smoke passes through the throat and enters the front side of the smoke chamber. Manual operated dampers can be installed only in connectors or chimneys serving solid fuel burning fireplaces or stoves. So it can't be installed in the instance of a gas burning fireplace or stove. The damper is located above the fire and is used to control the combustion and prevent conditioned room air from escaping up the flue. The damper must be made of a ferrous material. The damper must be operable from the room containing the fireplace. I've not personally experienced any where it wasn't, but I suppose it could be possible, depending on whether or not there was an addition. It's sometimes a pass through or something like that. But the damper has to be operable from the room where the fireplace is. When there's smoke rising through the throat opening above the combustion chamber, the open damper is designed to control the downdraft. When hot gases and smoke rise up through the throat, they pass up into the front side of the smoke chamber. The rapid upward movement of gases creates a downdraft on the rear side of the smoke chamber. One purpose of the open damper door is to direct the downdraft back up into the smoke chamber and prevent it from pushing smoke down into the room. So now we're going to talk about the fireplace smoke shelf and chamber. The smoke shelf is located behind the damper. It helps it helps the open damper change the direction of the downdraft, which is again a very critical component. A fireplace works well if the smoke shelf is deep. Some smoke shelves are curved. The smoke chamber is located between the top of the throat to the bottom of the flue. Smoke would enter the room without a smoke chamber. Its size is large enough to hold a lot of smoke. The interior surfaces of the smoke chamber are usually sloped and coated with about a half-inch thick layer of cement mortar. Sorry. There we go. So an ash dump is not required for every fireplace. It depends on the type of fireplace and the foundation of the house. Cleaning of the fireplace may be possible from the fireplace opening if it doesn't have an ash dump. The ash dump is usually located in the rear hearth if there's an ash pit constructed below the fireplace. The ash dump is essentially an opening into the rear hearth through which the ash and debris are passed. The ash dump is a pivoting metal door installed on a metal frame. The ash dump is typically made of cast iron. The homeowner generally cleans the fireplace by sweeping the cold ashes into the ash dump. The ashes fall downward and end up in the ash pit below, and the ash pit must have a clean out door. If the house has a slab on grade foundation, the ash pit might be not as deep, but it would still require a clean out of some type, usually accessed from the outside. This design of having the fireplace clean out door accessible from the outside may be used when the fireplace is located on an outside wall. For slab on grade foundations, a raised hearth will provide enough space for an ash pit under the fireplace. The clean out door would have to be elevated high enough above grade in cold weather climates to help prevent the door from being blocked by snow. The clean out for an ash dump must be made of ferrous material or a masonry door and frame built to stay tightly closed. And access for the clean out door should be provided and made readily available so that the removal of the ashes does not create a hazard. Sorry. Thank you guys for staying active in the chat. I'm just kind of keeping an eye on that. So a masonry chimney clean out is different from an ash dump clean out. A masonry chimney clean out is used to inspect, access, and clean the flue of a masonry chimney. Photos from an inspection of a masonry, the photos shown here are from an inspection of a masonry chimney clean out. This clean out was opened and debris was observed through the clean out. Additionally, the upper edge of the clean out opening was not at least 6 inches from the inlet. Corrections and further evaluations were needed. A cleanout is not required if the masonry chimney is used for a fireplace where cleaning is possible through the fireplace's opening. An example of a required cleanout would be if the home had an oil-fired heating system that was connected to a masonry chimney. The photo of the masonry chimney cleanout for a fireplace. So a cleanout for a masonry chimney should be made of non-combustible material, which again, hopefully should be obvious. The cleanout opening for a masonry chimney must be located within 6 inches of the base of the flue. The upper edge of the cleanout should be at least 6 inches below the lowest inlet opening, and the cleanout opening should be at least 6 inches in height. Exterior air, flue size, and glass doors. So factory built and masonry fireplaces must be provided with an exterior air supply to assure proper fuel combustion unless the room is mechanically ventilated. The exterior air intake must supply all of the combustion air from the exterior of the dwelling or from spaces within the dwelling ventilated with air outside, such as ventilated crawl space or ventilated attic space. The exterior air intake must not be located within the garage or basement of the house. The cross-sectional area of the chimney flue is based on the area of the fireplace opening. So one rule of thumb is that the flue area should be at least 1/10 of the total fireplace opening. A glass door enclosure may be installed at a fireplace opening. The enclosure helps lessen the amount of heated room air that escapes up the chimney. The rate of combustion can be controlled with the glass doors and by adjusting the damper and draft vents that may also be installed. So we're finally getting to prefab. So factory built or prefabricated fireplaces are found in many homes because they're less expensive to install than masonry fireplaces. So a lot of new builds are going to have the prefab fireplaces. They come in a wide range of styles. Some factory built fireplaces have zero clearance requirements to combustibles, which mean the house's wooden framing can come into contact with the fireplace's components. This is really, really frequent, really common on new builds. Factory built fireplaces operate in the same way that masonry fireplaces do. They share the same components. The room air can enter a factory built fireplace at the bottom of the unit near the floor and wrap around the firebox through the chambers. As the air is heated around the firebox, it flows upward. At the top of the factory built fireplace, air registers allow the warm circulating air to exit and enter the room. Some fireplaces are equipped with circulating fans, which would be forced hot air. Factory built fireplaces do not require a concrete foundation, although most factory built fireplaces are metal. Pre-manufactured modular masonry fireplaces are also available. These masonry models incorporate special engineering techniques, including venting systems. So a factory-built chimney should be installed according to the manufacturer's instructions. All prefab chimneys must have a label from an approved agency that states the type of appliance with which the chimney was tested for use, a reference to the manufacturer's instructions, and minimum clearances to combustibles, again, which might be non-existent, but we need that to be labeled. The manufacturer's instructions should contain every aspect of the installation of the chimney, including component assembly, clearances, supports, terminations, fire blocking or fire stops, and connections. Factory-built chimneys require no masonry construction. They're made of double or triple walled sections of metal pipe. Flanges and fittings are used to secure the fireplace and flue to the house's framing. Spacers provide proper clearance from combustible materials. The top of the factory built chimney has a storm collar to divert rainwater from the chimney pipe to the chimney flashing. A chimney cap must be installed on top of the flue pipe. If a factory built chimney is used with a solid fuel burner or an appliance with corrosive gases, the inside flue pipe should be made of stainless steel or have a porcelain coated surface. Chimneys for factory built fireplaces require specific clearances and support components. The openings through the ceiling and roof should be carefully sized and constructed to provide proper clearances. The openings through which the chimney passes should be blocked with fire stop spacers and support boxes. If the factory built fireplace is located on an exterior wall, a chase can be constructed around the chimney to contain and protect it. The exterior walls of the chase are typically sided with the same exterior covering material as the rest of the house. So, not a bad idea to know the difference between the chase and the normal body of a chimney. The refractory panel walls of a factory built fireplace require replacement if a nickel on its end can be inserted into the crack or when the surface of a refractory panel has abraded more than a quarter of an inch from the original surface. Replacement of the refractory panel should be completed by a qualified professional. So again, you don't necessarily need to stipulate that it needs to be replaced. That's not something that terminology doesn't need to be in your report. You're not going to say this needs to be replaced. You're just going to say, I recommend that a qualified chimney professional evaluate if you can see those defects. Wood burning stoves, definitely more typical in older homes, but you're starting to see some people go back into some alternate heating methods like wood burning stoves or pellet stoves. A wood burning stove, also known as a wood stove, is a heating appliance made from iron or steel that is capable of burning wood fuel. Unlike a standard fireplace, a wood stove is typically contained entirely within the living space rather than inset in a wall. Wood stoves come in many different sizes, each suited for a different purpose. Small stoves are suitable for single rooms, seasonal cottages, or small energy efficient homes. These models can also be used for zone heating in large homes where supplemental heating is needed, and they're very effective. Medium-sized stoves are appropriate for heating small houses or mid-sized homes that are intended to be energy efficient and as inexpensive as possible to maintain. So, large stoves are used in larger homes or older homes that leak air and are located in colder climates. To ensure safe and efficient use of wood-burning stoves, inspectors can pass along the following tips to their clients. Never, never, never burn coal. Coal burns significantly hotter than wood and definitely poses a fire hazard. Never burn materials that will emit toxic chemicals, such as wood that's been pressure treated or painted, colored paper, gift wrapping, plastic, plywood, particle board, or questionable wood from furniture. So this is meant to have just burn really clean wood. This isn't like a fire in your backyard that you can just kind of toss in whatever you want. Don't tell the local firefighters I said that. Even the backyard fire should really just have clean wood being burned. You should never burn wet wood. Generally speaking, it takes 6 months for cut, stored wood to dry out and be ready for use in wood burning stoves. You should never burn combustible liquids such as kerosene, gasoline, alcohol, or lighter fluid. So again, there's ways to get a fire started in one of these things. One of those is not to spray it down with some kind of an accelerant. Never, ever, ever, please let small children play near a lit wood burning stove. Like I said, the material is iron, usually cast iron, and it gets very, very hot on the outside. Unlike a standard fireplace whose sides are mostly inaccessible, all sides of the wood stove are exposed and they're capable of burning flesh or clothing. And never let the fire burn while the fire screen or door is open. So again, it's a very specific thing. It's not a toy. It's something that it needs to be enclosed. It needs to be viewed like an oven that has all of its sides exposed, which is definitely a sketchy thing if you have kids. So, you'll see this in a lot of older homes. Some people are putting them in now, but these are great things to tell your clients. Hey, especially if you see some indication that any of these little tips have been broken. Always use a grate to hold the logs so that they remain secured in the stove and they can the air can circulate adequately around them to keep the fire burning hot. Always keep the damper open while the stove is lit. Again, seems pretty straightforward, but this could be even tips that you could leave behind if you see a wood burning stove in somebody's house. You could have a little printout if it's a common thing in your area, especially north of the Mason-Dixon line. Although, again, down here in higher efficiency homes, people use them to supplement because electric heat can be expensive. And a lot of houses in the South use heat pumps, and that heat pump uses an auxiliary electric heat, you know, much less cost effective than a wood burning stove if you can put one in. So, no matter where you're located, you can just leave a little, hey, I was here, I inspected. Here's a few tips for maintaining a wood burning stove. And remember these safety tips. Always dispose of ashes outdoor in a water filled metal container. Always check the smoke alarms to make sure they're working properly. And periodically remove the stovepipe between the stove and chimney so that it can be inspected for creosote. Homeowners may want to hire a professional to do that for them, but it is something that should be done pretty regularly. So, efficiency and air pollutants. While federal and state governments crack down on vehicle and industrial emissions, they do relatively little to limit the harmful air pollution emitted from wood stoves, which is why it's helpful to tell people don't burn crazy things in them. But if they do, the government's probably not going to step in and say anything about it. The problem is so bad that in many areas, the smoke from wood stoves is the largest contributor to local air pollution. Ask the residents of Vermont. Smoke from wood stoves can cause a variety of health ailments from asthma to cancer. So, what should the inspector do? Verify compliance. Inspect for EPA certification label, which indicates compliance with the 2020 emission standards. Confirm the model year of the stove. Units manufactured after May 15th, 2020 must meet the updated standards. And educate your homeowner clients. Explain the benefits of upgrading to a compliant wood heating appliance, especially if the current stove predates the 2020 regulations. Highlight the health and environmental risks of older non-compliant stoves, and always check for state or local restrictions. Some jurisdictions may require stricter standards or ban the use of older, higher emissions stoves entirely. So the U.S. EPA, the Environmental Protection Agency, revised its new source performance standards, NSPS, for wood heating appliances, with the latest rules taking effect, like we said, May 15th, 2020. Those standards apply to all new wood heating appliances sold or installed in the United States. The current emission limits for wood stoves, cordwood, the emission rates are now limited to 2.5 grams of smoke per hour. Cribwood emission rates must not exceed 2 grams per hour. And cordwood testing more closely resembles real world use, while cribwood uses a standardized fuel configuration for testing. Pellet stoves, emission rates must not exceed 2 grams of smoke per hour, aligning with cribwood standards. And pellet stoves are considered one of the cleanest burning wood heated appliances. And those are really great. And again, a lot of people that are installing these types of stoves are using pellet stoves. So how does that compare to the older standards? The prior emission limits for wood stoves were 4.1 grams per hour for catalytic stoves and 7.5 grams per hour for non-catalytic stoves. The 2020 revision significantly lowered those limits, making older stoves non-compliant unless grandfathered in under certain local regulations. Although, to be honest, a lot of them are not grandfathered in just because it's such a health hazard. In Canada, the CSA standard remains the primary guideline. Wood stoves must emit no more than 4.5 grams per hour of particulate matter. In Quebec, stricter regulations often align more closely with the EPA's 2020 limits. The Quebec City bylaw, enacted on April 19th, 2021, aims to reduce fine particle emissions from wood burning appliances. The key provisions include certification requirement. By September 1st, 2026, all owners of wood burning appliances like stoves, fireplaces, furnaces must have appliances certified according to CSA B415.1 or to EPA standards. Emission limits for new installations. Appliances installed after September 1st, 2026 must meet the most recent certification standards with fine particle emission rates not exceeding 2.5 grams per hour. For furnaces or boilers, the maximum emission rate is set at 0.065 grams per megajoule. The ban on non-certified fireplaces starting on January 1st, 2024. The installation of non-certified decorative or ambiance fireplaces is prohibited unless purchased before that date, with a complete ban on their use effective by September 1st, 2030. The declaration requirement, the current owners of solid fuel appliances must declare them by April 1st, 2024, or within 90 days following the installation or removal of a new appliance. So we'll cover this real quick and then we'll go to break. Why the stricter emission standards matter. So one, for air quality improvements, reducing that particulate matter of emissions helps mitigate health issues like asthma and cardiovascular disease. Cleaner burning appliances reduce contributions to regional smog and fine particulate pollution. There's environmental benefits. Lower emissions mean less impact on air quality and reduced greenhouse gases associated with incomplete combustion. And consumer awareness. Homeowners benefit from more efficient stoves that burn less wood and produce less ash and creosote. So, to summarize that, the EPA's 2020 standards, all new wood stoves and pellet stoves must emit no more than 2.5 grams per hour for cordwood testing and 2 grams per hour for crib wood testing or for pellet stoves. In Canada, the emission rates are capped at 4.5 grams per hour, except in Quebec, which is probably going to enforce stricter standards. Home inspectors should verify compliance with those standards, ensure that stoves are properly labeled, and educate their homeowner clients about upgrading non-compliant appliances. So your main thing is looking for that labeling. And if you don't see the labeling, you're kind of going to call it out anyway, just because if you can't confirm it, then better safe than sorry.
We do have a couple questions, so we'll get those answered.
Yeah, let me see.
Russell asks, I never see masonry caps, crowns that extend past the edge of the brick with a drip edge. Even newly repaired caps are thralled to the edge. Is this a regional or jurisdictional accepted requirement?
That's a good question. You'd have to check with the local authority. It's supposed to extend about 2 inches past the outside edge. I'll agree with you. Mostly what I see in the North Carolina area doesn't extend past, and I usually just put the requirements in the report. I don't call it out as like a major safety issue if it's not extending out that far, but it's supposed to.
Should a gas fireplace have a damper?
No, and we'll talk about that later. If it's gas, it shouldn't have a damper because that damper, if it's not clamped, it could cause gas to back up into the home. So it sometimes you'll have a unit that gets switched over from wood burning to gas, and if it has a damper, a lot of times they'll just take it out, or there's a special clamp that I'll have. It's literally like the last slide we have. There's a little clamp that should be on there. You're not required to stick your head in there, but you could use a mirror or something. I would confirm that if it's a gas fireplace, the damper should either be removed or it's got to be clipped.
Right. And one more question. Is the chimney cap for wood style or is the chimney cap for wood stove also like B type? B type.
For a wood stove, that's a good question. I would think it's B type, but I'll have to look that up. Okay, so yeah, the type B and the type L are really mostly for gas-fired appliances because they're usually double walled. So yeah, wood burning appliances usually have a masonry chimney. They're usually not going to be type B. They may, if they're metal, if the flue inside is metal, it's going to be either stainless steel or some other kind of like non-corrosive metal. But a wood burning stove would not have a type B or even a type L.
Right. What do we tell the homeowner, the owner or the agent when they say we cannot open the damper because of the soot falling out?
Just like anything else, just like somebody, if you think there's a water leak behind the couch, you're not required to move it. And if they say we don't want to move it, you're just going to have to disclaim it in your report. And you don't necessarily raise a red flag and say, I think fill in the blank. Like you're just going to say, no deficiency could really be identified. Like whether or not the damper could be used. If it can be used manually, it's something that you're allowed to do. I know that people would probably shy away from that because anytime we operate anything, it's a potential liability. But if somebody says, look, don't touch that, and I don't want to touch it because we don't want soot to fall out, my personal way of dealing with that would probably be to put whatever their exact quote was in my report. Because if there's soot just like falling out of the damper, then you absolutely need to have it cleaned. Because again, that's at least a level one creosote buildup. To have that soot in there, if it gets to level two and level three, you have a really serious fire problem or a fire risk problem. So just to put a finer point on one of the questions, um, I was just doing a little side research on the when a crown is poured in place. I guess it's not always a legal code or requirement for that to extend past the outside face, but pretty much everybody recommends it. The current code's a 2021 IRC in earlier versions, still in force in most places as of 2025. It says that the chimney crown shall be constructed of a minimum 2-inch thick concrete or masonry, sloped for drainage, and provided with an overhang or a drip edge where the crown meets the chimney size. So it doesn't specify how far the overhang has to extend, but the commentary and the illustrations in the IRC show 1.5 to 2 inches of overhang past the brick on all sides with a drip edge. So it is a code requirement, and that's usually a minimum. So the International Residential Code is usually not going to. Most people would default to whichever is more strict. So if a local jurisdiction is for any reason less strict than the IRC, usually I don't even know if I'll address that as a possibility because usually the IRC is kind of a minimum and local jurisdictions will adopt that or a stricter standard. So I would say to answer that question more fully, there's not a specific requirement, but the commentary of the code usually clarifies the intention of the code. So the commentary says that 1.5 to 2 inches is pretty normal. So kind of an ipso facto thing. It's kind of required to have it to be 1.5 to 2 inches. So now that we got that, we'll continue. All right. So catalytic and non-catalytic wood stoves. Wood stoves are designed to burn wood efficiently while minimizing emissions. Two primary technologies are used in modern stoves to achieve this: catalytic combustion and non-catalytic combustion. Each has distinct features, maintenance requirements, and benefits that home inspectors should understand. So, tips for inspectors: check for proper use, look for signs of improper fuel use, creosote buildup, or discolored catalyst. Ensure owners understand that only seasoned wood should be used. Inspect the catalyst if applicable. You can check for blockages, warping, or other damage to the ceramic honeycomb. Verify whether the catalyst is still functional if the stove is older. You can evaluate the baffle in non-catalytic stoves. Look for signs of cracking, sagging, or deterioration in the baffle. And as always, educate your homeowner clients. Discuss the differences between catalytic and non-catalytic stoves, especially if they're considering replacement, and emphasize the importance of regular cleaning and proper operation to ensure efficiency and compliance with emission standards. So for catalytic wood stoves, they include a ceramic honeycomb catalyst coated with a reactive material, often platinum or palladium. The smoky exhaust from burning wood passes through the catalyst, where particulates and gases are burned at lower temperatures than in standard fire. This process significantly reduces emissions and increases efficiency by extracting more heat from the same amount of fuel. Key features: the high efficiency is due to a thorough combustion of particulates and gases, so that's a great feature. Longer burn times. Catalytic stoves maintain steady heat output over extended periods, making them ideal for overnight use. And lower emissions. They meet or exceed stringent emission standards, often outperforming non-catalytic models in that regard. The maintenance and drawbacks of a catalyst, excuse me, of a catalytic. The catalyst degradation. The catalyst will degrade over time and typically lasts up to 6 seasons if maintained properly. And that's a big if. A lot of people are not big on maintenance. So it's something that, something to keep in mind. Using inappropriate fuel like treated wood or wet wood or failing to clean the stove can lead to premature failure. So it's not just an emission thing in terms of the treated wood or the wet wood of burning weird things. It can lead to premature failure. So the cost of catalytic stoves are generally more expensive than non-catalytic models. And the maintenance, they do require regular cleaning of the catalyst to ensure proper airflow and operation. The catalyst will eventually need replacement. That's just the reality, adding to the long-term costs. Again, 6 seasons if you're maintaining it properly, which is pretty, I don't want to say it's totally rare and sound like a jaded inspector, but people that have these don't maintain them often. So non-catalytic wood stoves, they rely on 3 design features to achieve clean combustion without the use of a catalyst. They have preheated combustion air that's introduced from above the fire. That ensures the complete combustion of gases and particulates. The firebox insulation retains heat, which promotes high combustion temperatures for cleaner burns, and a large baffle directs air and gases through the firebox, creating a longer path for combustion and maintaining those higher temperatures. So the key features of a non-catalytic stove are that they don't have a catalyst, so they're a bit simpler to operate and maintain, and they're a bit lower cost up front. They're generally cheaper to purchase than the catalytic stoves. And the ease of use, they have fewer components to monitor and replace, which is always kind of a big selling feature. So some of the drawbacks of having those non-catalytic stoves, the baffles will deteriorate, and those are the things that redirect the air and gases, and they deteriorate over time due to constant exposure to high temperatures. They'll need to be replaced periodically, although less frequently than the catalytic components. Efficiency, they are efficient stoves, but they're usually a little bit less efficient than the catalytic models, and the burn times are usually a bit shorter. That makes them less ideal for overnight heating. The following telltale signs indicate that the fire in a wood-burning stove suffers from oxygen deprivation and incomplete combustion, which will increase the emission of particulates into the air. So if it emits dark, smelly smoke, an efficient stove is usually going to produce very little smoke. So if it's emitting dark, smelly smoke, it's probably suffering from oxygen deprivation and incomplete combustion, which is not favorable. So if you have one of these stoves and there's a smoky odor in the house, if there's soot on the furniture, if you check the temperature, if it's burning at less than 300 degrees Fahrenheit, it should read above 300, usually between 300 and 400 degrees. So if it's less than 300, you're usually getting that incomplete combustion. And if the flames are dull and steady rather than like bright and lively, again, probably some oxygen deprivation that's leading to incomplete combustion. So to ensure efficiency, homeowners should follow these recommendations. And again, if you run into a lot of these, you can put these on some kind of a card that you leave behind after you inspect. Purchase a wood-burning stove listed by the Underwriter Laboratories or the UL Laboratories. Stoves tested by UL and other laboratories burn cleanly and efficiently. Burn only dry wood. Wood that has a moisture content of less than 20% burns hotter and cleaner than freshly cut wood, which may contain half its weight in water. Burn hard woods such as oak, hickory, and ash once the fire has started. So softwood such as pine, they'll go up quicker, but they also burn up quicker. So if you want to start the fire with materials like pine, then get that fire going, and then the logs that you put in, try to burn hardwoods because those will burn a little bit longer and keep that steady heat. Make sure the stove is properly sized for the space. Stoves that are too large for their area burn inefficiently. Burn smaller wood pieces rather than larger ones. Smaller pieces of wood have a larger surface area, which allows them to burn hotter and to burn cleaner. So the inspection process. Again, you can see this gentleman doing what I would do and sticking his head in there to see. You can use a mirror or something like that. Again, I don't think that it's not required to inspect the flue, but inspecting that inside firebox and all the things that you can readily see. Again, if a homeowner can stick their head in there, I think you can stick your head in there and make sure you at least see all the things that they see, but with an inspector's eye. So the inspector should inspect for the following: solid burning fuel appliances or fireplaces improperly located where gasoline or other flammable vapors or gases are present. The thing is, just to keep in mind, as far as safety goes, we've got to stay aware. Stay outside of the business as usual mindset where we're just kind of working through, getting our report done, looking at our stuff, only the stuff we need to focus on. One of the things you kind of need to focus on is huge safety concerns like this. If you need to be told that it's not a good idea to have a fireplace really close to gasoline, like, come on. We've gotta pay attention to these things because that's the first thing that somebody else is going to notice. Like, holy smokes, I can't believe that inspector just walked right through and didn't notice that. If there's a glaring safety concern, it's not, I mean, safety is just implicit in what we do. It's implied in pretty much every area of what we're doing. It's the number one goal for us is to keep ourselves safe, but also to keep our clients safe. And so if you're walking through an area where there's a fireplace or a solid fuel burning appliance and you see gasoline or other flammable vapors or gases present, you've got to call that out. You should inspect for any unused openings in chimneys or flues. The lack of a smoke detector, again, big safety thing. A smoke detector should be installed in the same room as the fireplace. So some of these more open floor plans, I get it. You're going to have to look around a little bit sometimes, but you got to call out the lack of a smoke detector. You got to call out the lack of a carbon monoxide detector. When there's incomplete combustion, that results in carbon monoxide. So carbon monoxide detector should be installed in the same room as the fireplace. That's not even just a code thing or a firefighter thing. That's like just 101 safety stuff. Incomplete combustion leads to carbon monoxide production, and there needs to be a carbon monoxide detector installed in the same room as a fireplace. You should inspect for a combustible lintel above the fireplace opening. That fireplace lintel should not be made of wood. This isn't the 1700s. We need to have steel or iron, something that's not combustible. Combustible material within 6 inches of the fireplace opening that projects out 1.5 inches or less from the face of the fireplace. Combustible material within 12 inches above a fireplace opening that projects out more than 1.5 inches from the face of the fireplace. So if you get a nice big mantle, you want to hang your Christmas stockings on there, make sure it's more than 12 inches above. A throat or damper located less than 8 inches above the fireplace opening. A manually operated damper that does not operate or close properly, and a damper or damper component that has rust or corrosion. So again, if you see rust or corrosion, if you're looking at a damper or damper component that has rust or corrosion, even if it looks complete now, that rust or corrosion could eventually cause that damper to fail, which could create like a backdraft and some issues there. The inspector should inspect hearths that are not made of concrete or masonry and that have a thickness of less than 4 inches. Those would be defects. The inspector should inspect the hearth extensions that have a thickness of less than 2 inches, are less than 16 inches in front of, or less than 8 inches beyond each side of the fireplace opening. So they've got to be, 6 square feet or more, and are less than 20 inches in front of, or less than 12 inches beyond each side of the fireplace opening that is greater than 6 square feet. The inspector should inspect hearth extensions, and chambers for joint separation, damage, and deterioration. Again, these are things where you're just looking to see, generally speaking, if everything looks right. If you had no other knowledge of how this is supposed to be, if you don't know all the measurements, which again, you should kind of commit those to memory. But if you don't, at least, at minimum, look and see, does everything look okay? Does everything look connected well? Does some of those mortar joints, just look at them, just see, just generally speaking, does it look like something you would want to have in your house? Those are just, again, a couple easy points of like, when you're first getting into this, or even when you've been doing this a while, the first thing that you should look at is not necessarily dive right into the specs and these numbers that we all throw around. just give it a general once over and see, does anything look like it's separated? Does it look like it's broken? Does brick look like it's spalling? Just take a look and see, does everything look okay? And then you can start applying some of these more specific standards once you've just looked to see, like, does it look like it's broken, right? So inspection of a single wall metal chimney. The inspector should inspect for exposed interior single wall metal chimneys that are not continuously exposed where they extend through closets, storage areas, or habitable spaces where the surface of the chimney could come into contact with people or combustible materials, right? That's something you're going to want to call out. For the inspector should inspect for interior single wall metal chimneys for distances less than 18 inches away from wood frame walls or combustible materials, sized 18 inches or under in diameter that are less than 2 inches away from non-combustible walls, and sized more than 18 inches in diameter that are less than 4 inches away from non-combustible walls. The inspector should inspect for distances between exterior mounted single wall metal chimneys that are less than 2 feet away from doors, windows, or walkways, that are less than 18 inches away from wood framed walls or combustible materials, sized 18 inches or under in diameter that are less than 2 inches away from non-combustible walls, and sized over 18 inches in diameter that are less than 4 inches away from non-combustible walls. The inspector should inspect for missing thimbles where chimneys pass through combustible roofs. A lot of roofs are combustible. The inspector should inspect for chimneys that terminate less than 3 feet above the highest point where they pass through the roof surface, 2 feet above any portion of the building within 10 feet, 3 feet from adjacent buildings or building openings, or 10 feet above grade for 10 feet above grade or walkways. The inspector should inspect for chimney outlets that jeopardize people's safety, overheat combustible structures, or that might cause flue gases to enter nearby building openings. The inspector should inspect the crowns of masonry chimneys for slopes that direct water into flues. It's something that personally I've seen little of. Usually the slope is at least correct on those crowns, but you definitely want to take a look at it and make sure it looks like a crown and not like a bowl. So here's a table for the maximum fireplace opening in square inches for rectangular flues. The inspector should inspect for galvanized flues and connectors. Flues and connectors should not be galvanized. It needs to be corrosion resistant. Inspect readily accessible and visible flues for rust and corrosion. Inspect for masonry chimneys that are not lined. All masonry chimneys should be lined. And I would hope that it wouldn't happen in a newer build. So I'm usually on high alert for this in older homes, pre-1960s-ish. Some of those masonry chimneys, the codes, it may even be further back than that, but the codes didn't necessarily require that those were lined. So you want to take a look at that. And again, even if something's grandfathered in, as an inspector, we're not necessarily worried about whether or not they're passing the code for when the house was built. That is something that a code inspector would be concerned with, whether or not something's grandfathered in. But if you see something that doesn't look right, you say something, you put it in your report. So if a masonry chimney is not lined, it doesn't really matter when it was built. It's not safe. Okay. Inspect for linings that don't extend the entire length of the chimney to a level of 4 inches or more above the masonry cap. So the cap, the crown, the splay, the wash, whatever you want to call it, the flue liner should extend 4 inches above that cap. You should be able to see it and take a picture of it. If you can't see that it extends above the cap, you got to call it out. Inspect for liners that are visibly softened, cracked, deteriorated, or damaged. And again, that should be pretty visually obvious. Inspect readily accessible and visible flues and liners for excessive accumulation of creosote, soot, and other combustible material. And we'll talk later about, again, I've mentioned it a couple times, but I'll show you pictures of the different levels of creosote buildup. Even a level 1 is something that I would call out because it's something that a chimney sweep needs to kind of come in and clean out. So that it doesn't lead to a level 2 or 3. So if you want to specify what level you think it is, you can, because they're pretty discernible. But either way, you just want to call it out if it looks like there's a creosote accumulation, because it is combustible. Inspect flues that have two or more openings at the same level, and inspect for venting into the space around around and between the chimney liners. The remaining space surrounding a chimney liner should not be used as a vent. Should not be used as a vent. The inspector should inspect the size of a flue, if visible, to compare it to the size of the fireplace opening. That relationship is the most important factor in achieving sufficient draft. A flue that is too small relative to the fireplace opening will be unable to lift and remove hazardous flue gases to the outside. So, the inspector should inspect for connectors from solid fuel burning appliances that have a rise to the chimney of less than a quarter inch per foot. So you can measure that with a ruler. It's a quarter inch of rise for every foot of run. So if you can measure a ruler across 12 inches and it's anything less than a quarter of an inch down from that point, then it does not have a sufficient rise. So you should inspect for connectors that are not as short or straight as possible. And again, that's kind of a judgment call in one sense, but it should be pretty visually obvious if something takes a bend that it doesn't need to take to get to where it's trying to go. That's not as straight as possible. And if it's longer than needed, then it's probably going to have an unnecessary bend in it as well. You should inspect for connectors that are covered with insulation and inspect for connectors of natural draft appliances connected to the positive pressure side of a mechanical draft system. The inspector should inspect for the improper installation of larger connector pipes entering a flue above smaller connector pipes. The smaller appliance vent connector should connect to the chimney above the larger one. If there are two or more vent connectors entering a common gas vent, chimney flue, or single wall metal pipe, the smaller vent connector pipe must enter the vent, flue, or pipe at the highest point allowed. If there are two or more vent connector pipes entering one chimney flue or vent, the pipe penetrations must be at different levels, or the connectors must be installed at an angle of 45 degrees or less relative to the vertical. Vent connectors for Category 1 appliances should not be connected to any vent connector pipe of a mechanical draft system operating under positive static pressure. This is an illustration of two appliances and their vent connectors entering the same chimney flue. The smaller vent connector pipe is higher than the larger one. Cleanouts. The inspector should inspect cleanouts for doors and frames that are not made of ferrous material, precast cement, or other non-combustible material. If it seems like it's made of a combustible material, that's obviously a pretty big problem. Inspect combustible materials projecting beyond the faces of chimneys that are within 18 inches of cleanout openings. Inspect for combustible materials stored within 18 inches of cleanout doors. Inspect cleanout doors that are obstructed or do not close tightly. Inspect the interior cleanout's lower edge for heights above the lowest accessible floor level that are less than 16 inches. Inspect the exterior's cleanout's lower edge for heights above grade that are less than 16 inches, and inspect the base of fireplace chimney flues for distances that are not between 6 and 12 inches below the bottom edges of their cleanout openings. All right, we're going to talk about preventing chimney collapse. Let's do our part. Chimneys are, if you didn't already guess, among the heaviest and most structurally vulnerable of all exterior components of a building. Accidents caused by their collapse can lead to death, which is not a joke. I mean, those things are really seriously heavy. A collapse can also cause costly structural damage to the building and its surroundings. Inspection, maintenance, and preparedness are critical safeguards against chimney collapse. And again, if you walk by a chimney and don't recognize something like that, this is like the most common thing that is said after we leave a house is like, can't believe the home inspector didn't catch that, right? So if you see a chimney that looks like it's buckling, like a masonry chimney looks like it's buckling in the photo here, that stucco's cracking, does that stucco crack? Is that a settling crack? Does that necessarily mean that chimney is just going to fall over? Not necessarily, but man, I sure as heck would hope that it doesn't. And if it did and I didn't say something about it, then I don't know what the implications in terms of liability are, but people are always looking for somebody to blame, and a home inspector is always a great person to blame for whatever reason. So inspection, maintenance, and preparedness are critical safeguards against chimney collapse, right? Wind and other elements may cause an already weakened chimney to collapse. An elderly man in Britain was crushed by a wind-toppled chimney as it fell from the roof of the managed care facility where he lived. This case is unfortunately fairly unremarkable, as such accidents occur often for a variety of reasons, from weathering and wind to falling tree limbs in poor design. I saw a tree that had hit a roof and knocked the top of the chimney right basically into the living area, where luckily nobody was standing at the time when it happened, but it was already weakened, and that tree just kind of gave it its last push over the cap, everything. It was a masonry chimney, and there was a whole big chunk that crushed through the roof and fell into the foyer. So by the hundreds chimneys collapse by the hundreds during major earthquakes, typically snapping at the roof line. More than one half of the homes in Washington state inspected by FEMA, followed by the Nisqually earthquake in 2001, sustained chimney damage. Chimney collapses were widely reported during the massive 7.1 magnitude earthquake that struck New Zealand in September of 2010. Earthquake damage and injuries can be caused in large part by bricks and stones as they fall from chimneys onto vehicles, structures, and people. And for masonry components like that, it almost seems like, would wind really pick something up and toss it? If you live by the coast, you'd know that yes, it can. So if you're, say, doing a roof inspection and you see a very badly deteriorated crown, a lot of times once that crown starts to crack and deteriorate, the brick underneath is, exposed to a lot of excess moisture. Depending on the weather, you can go through freeze thaw cycles, and those bricks can kind of come loose. And honestly, a bad enough wind, I know a brick seems heavy, but with a serious enough wind, that can blow right off the roof. Those collapses happen suddenly and without warning. They can also cause implosion type destruction as the chimney makes its way through the roof in the attic, demolishing part of the living space and injuring occupants below. Like I said, the inspection that I saw. For these reasons, it's crucial that chimneys, especially in seismically active regions, be inspected periodically for signs of weakening. Following an earthquake, it's even more vital that chimneys be inspected for indications of imminent or future collapse. So again, even if it wasn't bad before an earthquake or some seismic occurrence, you should really be inspected afterwards, because you're going to start to see those the joints start to fail. So chimneys should be inspected for the following defects: mortar between the bricks or stones that crumbles when poked with a screwdriver. Again, you don't need to stab it. It's just a normal poke. You just kind of jab it a little bit, and that stuff will come out like powder and crumble. Missing or insufficient lateral support, such as steel straps used to tie the chimney to the structure at the roof and floor levels. And you can usually see that in the attic. Building codes in some seismically active regions require internal and external bracing of chimneys to the structure. Mechanical damage to the chimney, such as that caused by falling tree limbs or scaffolding. So again, sometimes somebody's performing work around a chimney and they knock it with a tool, or scaffolding bangs into it, or even a falling tree limb that hits. That can cause damage. It's going to lead to long-term issues if it's not called out immediately once it's seen. Visible tilting or separation from the building. I've seen this a lot. Any gap should be frequently measured to monitor whether it's increasing, because when you do have settling and things like that, you can have a gap that's created, but maybe it doesn't get any bigger, right? Because it's not actually leaning or tilting. It's just kind of a separation that occurred to the building material through the home settling. So if you do see a crack or something like this, again, like we're looking at in this picture, there's a big crack there. So you don't need to sound the alarm from the rooftop that your chimney is about to fall over and someone's going to die, but it is important to call it out. And I might put in my report what a good monitoring strategy might be for. There are actually stickers or things like that that you can put on foundation walls and in this case, this chimney, you can monitor something to see if that gap seems to be widening. If it's getting worse, then it definitely needs to be addressed. And sometimes it's not getting any worse. Um, Sorry, chimney footing defects include the following. Undersized footing, which is a footing cast so thin that it breaks or doesn't sufficiently extend past the chimney's base to support its weight. A deteriorated footing caused by weathering, frost, loose or poor quality construction, and poor soil below the footing, including eroded, settled, or otherwise weakening soil, frost heaving, or expansive clay beneath the footing. So again, these are not things that are always going to be present, but you need to know how to, again, at the most basic level, look and see if something looks generally correct to your eye. You're an inspector, you're a professional inspector. You see some homes, if not a lot of homes. And so you should hopefully be able to tell if something doesn't look quite normal, if something seems like it's sinking more than it should, if something seems like it's heaving more than it should. Take a picture of it. And the InterNACHI forums are a great place for stuff like that. If you're not totally sure if what you're looking at looks right, toss it in the forum. Be ready. If somebody calls you clueless or something like that, just like let those guys fall off to the side and take all the useful information that comes out. Because the InterNACHI forums are a really great place where a lot of professionals share some really super useful knowledge. So don't be afraid to take a picture and shoot it off to some inspectors that you know, including inspectors that you don't know. So a more thorough inspection performed to the International Phase 1 standards of practice for inspecting fireplaces and chimneys may also be considered. Inspectors may want to advise their homeowner clients to take these additional precautions. Attach plywood panels to the roof or above the ceiling joist to act as a barrier between falling masonry and the roof. So again, if you've got a chimney that's going up into the attic space, you can recommend to somebody, hey, doesn't hurt to install some panels of plywood over the rafters in this area so that if a part of that chimney does fall, if it falls in between the floor joists or the ceiling joists, all it's got usually is drywall or plaster or something like that it's just going to bust right through. So especially if it's in a seismic area or something like that, that may even be code. I don't live in an area like that, and I have inspected in 16 different states. None of them are really high seismic areas, so I don't know if that's a code, but I would think that it should be. If it's like Los Angeles or something, it'd be nice if you have a masonry chimney, you'd want some plywood installed across those rafters in the attic. Maybe recommend to strengthen the existing chimney by repairing weak areas. Tear down the chimney and replace it with a flue or a stronger chimney. Keep in mind that tall, slender masonry chimneys are the most vulnerable to earthquakes, weathering, and other forms of wear. However, even newer reinforced or metal flue chimneys can sustain significant damage and require repair. So be careful what you're recommending to someone. If you say, man, you do much better with, just a flue that comes up with a chimney chase built on the outside, that comes with its own issues as well. I've seen chimney chases tear right off the house and open up a big hole. So make these recommendations when you see it most fit. You may recommend to relocate children's play areas, patios, and parking areas away from a damaged chimney. And again, hopefully a damaged chimney that we're calling it as damaged, the next step for that chimney should be a repair so that it doesn't collapse. But if you see something damaged, you can make these recommendations and just say, hey, it looks like your grill is located right under this damaged chimney. Maybe move your grill. Instruct family members to get away from chimneys during earthquakes. And again, hopefully that goes without saying, but if you live in a seismic area and you have a chimney like that in your house, if an event is suspected, then get away from that thing. In addition to collapse hazards, leaning chimneys can also make the fireplace dangerous. Hearth cracks, side cracks in the fireplace, openings around the fireplace, and chimney damage all present the risk that sparks or smoke will enter the living space or building cavities. Check for evidence of fireplace movement. Following an earthquake, homeowners should have their chimney inspected before using the fireplace. You should also contact your local building department to obtain required permits before starting any significant construction that may affect the chimney structure and or its supports. So I've seen a lot of Additions put on the side of, like, I'm in North Carolina, so there's a lot of like farmhouses, and a lot of times those older farmhouses are just those long, kind of skinny, not deep front to back. So people will put additions on, and if you're putting an addition on like around the outside of a chimney, especially keep in mind if that's an ash dump clean out that's on the exterior. But just generally speaking, if someone's doing construction around a chimney, make sure you contact your local building department and get a permit. Commercial chimney collapses are pretty rare, but they do deserve mention because of the devastation they cause. In one terrible incident in central India, more than 100 workers were killed when a 900-foot tall chimney collapsed on a construction site. One of the worst construction site disasters in recent history. The collapse was blamed on heavy rain. While safety standards are generally more stringent outside of India, commercial chimneys everywhere require inspection. In summary, chimneys should be inspected to prevent expensive and potentially deadly collapses. And we are sometimes the only line of defense. We're looking at things that sometimes people don't really pay attention to. Again, even this photo is just a good example of, some people might think, well, it's just a crack. They're not really thinking in terms of load path. They're not really thinking in terms of danger, safety. They're just aesthetics. It's a crack. It's not so nice, but sometimes things crack, right? So we want to be that line of defense where we're calling things out that are not safe. So water damage. This is InterNACHI's chimney diagram here, that chimney cap that Ben was pointing to earlier. So all masonry and factory built fireplaces and chimneys can be adversely affected by direct contact with water. All chimneys can deteriorate from prolonged contact with water. And again, masonry components like cinder block and brick, they are not non-porous. They are porous, and water can penetrate those things, especially if held there. Like, you'll usually see it in a basement with cinder block walls. You'll have that hydrostatic pressure kind of forcing the water inside, and that's where that efflorescence is coming from. But those things are not impervious to water penetration. And during freeze thaw cycles, moisture has penetrated, the materials will freeze and expand, and it will stress the material out, which can also cause rust in steel and cast iron. So again, that is to say, if you're looking at a lintel that is exterior, so if you're seeing this is not necessarily chimney specific, but if you're looking at a brick facade with a big garage door with a metal lintel, look for rust on that lintel. Sorry, looking at the chat. So the inspector should check for efflorescence, like we just talked about, and we can see in that photo. Rusted dampers, deteriorated masonry, which in brick is usually spalling and things like that. Rusted or corroded metal, wood rot at nearby framing, water stains, clogged cleanouts, deteriorated mortar joints. And again, you can see that visually, but also, I don't know if you guys do, but if I'm inspecting, say, like an outdoor deck, I'll have some kind of a probe with me, not to aggressively attack something and damage it, but just to probe something and see if it is already damaged. That's a great thing to do with mortar joints as well. Just give it a gentle poke and see if some things start to come loose. If they do, definitely call it out. Look for a cracked flue lining, damaged hearth, a tilted chimney stack, and settlement cracks. Water damaged mortar joints. Water can easily penetrate deteriorated mortar joints in chimneys. And that's actually, I've seen it as a roof specialist. I've seen a lot of leaks that people think is coming from the chimney flashing is actually coming from brick chimneys that need to be repointed. So you'll see a lot of deteriorated mortar joints can look cracked, weathered. They'll have loose chunks coming out of them. And a common repair for those mortar joints is repointing, like I just said, where the existing mortar joint is cut out and the joint is repacked with new mortar. And that should hold you for a while. Install a cricket to stop or prevent leaks. So if the chimney is located on the low side of a roof where water runoff is directed against it, the installation of a cricket will afford additional protection against water leaking into the home. A cricket is a water deflector that serves to direct rainwater away from the chimney. A cricket is recommended for a chimney that's more than 30 inches wide. Just ask Ben Gromyko himself about such a thing. Crickets are especially important for chimneys on steep roofs. And again, you can ask Ben Gromyko what kind of a fun experience we had on his roof with this. Efflorescence is the white chalky powder that you might find on the surface of a concrete or brick wall. Like we showed in that lower right photo, it's chalky, it's white, it's powder. It will come off if you brush it. It can be a cosmetic issue, or it can be an indication of moisture intrusion that could lead to a major structural and indoor air quality issue. The home inspector should understand what efflorescence is in order to recognize potential moisture problems. So here's a few tips that you can offer your clients so you'll understand the differences. Pinched between the fingers, efflorescence will turn into a powder while mold will not. So if you see that white substance on the wall, we hopefully will know the difference, but a homeowner is almost never going to know the difference. So it can look like mold. It's not mold, it's more powdery, whereas a white mold like that will almost seem a little bit more fuzzy. And if you're so bold as to pinch it between your fingers, it will not like powder up if it's a mold. Efflorescence forms on inorganic building materials while mold forms on organic substances. It is possible for mold to consume dirt on brick or cement. So if you've got dirt on that cement wall, mold can form on that organic substance that's on the inorganic substance. But if it's kind of just a clean cinder block wall, you're not going to have mold building up on it. Efflorescence will dissolve in water because it's just a mineral that was already in water. Mold will not. Efflorescence is almost always white, yellow, or brown, while mold can be any color imaginable. I've seen purple, I've seen black, green, all the above. But efflorescence is kind of in that color palette that you would expect a natural mineral to be, right? A yellowish, kind of a brown hue to it. Maybe this, I've seen it mostly just this white. It's mineral content inside the water that's being forced through, and that water evaporates and the mineral stays on the wall. If the substance in question is purple, pink, or black, it is definitely not efflorescence. Aside from mold, the following conditions can result from excess moisture in a residence: fungi that rot wood, water damage to sheetrock, and reduced effectiveness of insulation. Inspectors should note in their inspection report the presence of efflorescence because it generally occurs where there is excess moisture, a condition that also encourages mold growth. Prevention. An impregnating hydrophobic sealant can be applied to a surface to prevent the unwanted intrusion of water. I helped my brother dig out the outside of his foundation because he was getting hydrostatic pressure pushing water in. And so we dug out a good bit around and put one of these coatings on. It will also prevent water from traveling to the surface from within. In cold climates, this sealant can cause material to break during freeze-thaw cycles. So you have to be careful what climate you're in when you apply this. So during home construction, bricks left out overnight should be kept on pallets and covered. Moisture from damp soil and rain can be absorbed into the brick. Install capillary breaks, including polyethylene sheeting between the soil and the building material, such as concrete. Removal. Pressurized water can sometimes be used to remove or dissolve efflorescence. An acid, such as diluted muriatic acid, like you put in your pool, can be used to dissolve efflorescence. Water should be applied first so that the acid does not discolor the brick. Following the application, baking soda can be used to neutralize the acid and prevent any additional damage to the masonry. Muriatic acid is toxic, and contact with the skin or eyes should be avoided. Again, if you have a pool, you probably already know this. A strong brush can be used to simply scrub the efflorescence off. The use of water to remove efflorescence may result in the reabsorption of crystals into the host material, and they may later reappear as more efflorescence. So you may exacerbate the issue. It is advisable that if water is used in the removal process, that the masonry is dried off very quickly so that doesn't happen. In summary, efflorescence is mainly just a cosmetic issue, but it indicates a potential moisture problem, and inspectors should know how capillary forces can cause structural damage to building materials and educate their clients about efflorescence and the potential problems that it might cause. So, porous building materials. Concrete, wood, brick, stone, they're all porous. I know that when we're kids, we don't think that might be true, but masonry materials, wood, they're all porous materials, and those can absorb or wick water by a process called capillary action. As water moves through the porous material, salts can be drawn with it. So concrete, wood, brick, stone, and mortar are porous materials that contain salts. The ground that these materials can come into contact with also contains salts. Capillary action can literally suck water and transport through the building material. Porous building materials are capable of wicking water for large distances due to capillary action with a theoretical limit of capillary rise of about 6 miles. That's 6 miles directly up. Okay. So think of a tree and how it can transport water from its roots all the way to its leaves. That's capillary action. And it's really powerful. So when you add salt to that capillary process, it can be really destructive. Salts dissolve by groundwater, can be transported by capillary action through porous soil. Building materials in contact with that soil will naturally wick the water inward and upward. So if you take a concrete footing, they're typically poured directly into soil without any capillary break. That's called rising damp. That's the beginning of how water can wick upward into a structure. Okay, like we said, 6 miles upward is the limit. So it has destructive pressures to it. When the capillary flow of water reaches the surface of a building material, evaporation occurs. As the water evaporates, salt is left behind. As this evaporation of capillary flow continues, the salt concentration increases through the process of osmosis, which creates imbalance. Nature abhors imbalance and always wants to put things back into equilibrium. Like if you think about heat transfer, there's this constant desire and attempt for nature to reach equilibrium. To reestablish equilibrium through osmosis, water rushes towards the salt deposit to dilute the concentration. This rush of water creates massive hydrostatic pressures within the porous materials, and these pressures are very destructive. The pressure from osmosis can create incredibly strong hydrostatic pressure that can exceed the strength of building materials, even concrete. So here's some examples of how that pressure translates. Diffusion vapor pressure, 0.3 to 0.5 psi. Capillary pressure, 300 to 500 psi. And osmotic pressure, 3,000 to 5,000 psi. So osmosis can create pressure that's greater than the structural strength of concrete, which is usually 2 to 3,000 psi. The action of water rushing to the surface due to capillary action creates incredible forces that can cause materials to crack, flake, and to break apart. Yeah, don't be shy on the chat. If you guys, if I breeze past something that you need, definitely shoot it in the chat. I'll try to make up a little bit of ground here because we got another hour and we got some stuff to get through. So, we discussed the osmotic pressures that can be really, really high with efflorescence. When it leads to those strong pressures, greater than the strength of the building material, the material literally breaks apart, and that's usually called spalling. So hydrostatic pressure can cause spalling, but spalling can also be caused by freeze-thaw cycles in building materials that have a high moisture content. So both efflorescence and spalling can be prevented with capillary breaks, such as installing a polyethylene sheet under a concrete slab. So kickout flashing, this is probably one of the more common things that I've had to call out because it's very often not installed. If you just look really closely, you can see that the step flashing for the roof does not continue as far as the hole in the siding does that the roof needs to be accommodated for. So if there's no kickout flashing, the water is going to run down and bleed in behind the exterior cladding. So when the kickout flashing is installed properly, it provides excellent protection against the penetration of watering into the building envelope. Several factors can lead to rainwater intrusion, but a missing kickout flashing in particular often results in concentrated areas of water accumulation. And if you guys are using infrared in your inspections, I can't tell you how many times I've seen the water go past where this kickout flashing should be, and there's just rotted sheathing behind the wall here. And so people will start to see like, oh, I think there might be a little leak in this room here. I don't know. There's a little stain. Infrared's showing like this huge, thermal anomaly. Come to find out, they tear some stuff apart and the whole wall sheathing was rotted because this goes on in small amounts for years without anybody ever really noticing. So InterNACHI inspectors should make sure kickouts are present where they're needed, which is anytime the wall extends out past further than the roof, and that they're installed correctly. Water penetration into the cladding can occasionally be observed on the exterior wall in the form of vertical water stains. Although you cannot rely on visual identification, alone. That's why I say infrared is super useful for that. Inspectors may observe the following problems associated with a kickout. It was never installed. It was the kickout need for kickout flashing was developed fairly recently, and the builder may not have been aware that one was required. The increased amount of insulation and buildup wrap that is used in modern construction makes buildings less breathable and more likely to sustain water damage. So kickout flashings prevent rainwater from being absorbed into the wall. The following locations where kickout flashing installation is critical. Anywhere a roof and exterior wall intersect, where the wall continues past the lower edge of the roof and gutter. If a kickout flashing is absent in these locations, large amounts of water may miss the gutter, penetrate the siding, and become trapped in the wall, like we said. And where gutters terminate at the side of a chimney, kickout flashings need there too. The kickout was improperly installed is another thing that you're going to want to look for a problem associated with kickout flashing. The bottom seam of the flashing has to be watertight. And if it's not, water is going to leak through the seam and might penetrate the cladding anyway. And the angle of the diverter should never be less than 110 degrees. Another thing to look for is if a kickout is modified by a homeowner. Homeowners who don't understand what the importance of that kickout is might choose to alter them because they're not very good looking pieces of flashing, to be honest with you. And any visible flashing is not usually made to be pretty. It's a very, very functional material. So a lot of times people will shorten the height of it to less than what the standard is, which is 6 inches. Some manufacturers do permit it to be 4 inches, and that's going to greatly reduce their effectiveness. So kickout flashings should also be the same height as sidewall flashings. So if that helps you. Homeowners may also make the kickout flashing less conspicuous by cutting them flush with the wall, which also makes them less effective. And so in summary, the kickout needs to be present and properly installed in order to direct rainwater away from the exterior roof covering material, particularly at chimney locations. This is a big one for exterior chimneys because that chimney is usually like 50% in, 50% out. So that wall is extending out past the roof, and you always need a kickout flashing there. International Phase 1 Standards of Practice. So the International Phase 1 Standards of Practice for inspecting fireplaces and chimneys. About these standards for inspecting fireplaces and chimneys. Although this standard applies to both commercial and residential fireplaces and chimneys, it exceeds the requirements of both InterNACHI Home Inspection Standards of Practice and the International Standards of Practice for inspecting commercial properties. The inspection shall include examination of readily accessible and visible portions of solid fuel burning, low heat fireplaces and chimneys. The purpose of this document is to establish international standards for the inspection of fireplaces and chimneys. This document also provides universal fireplace and chimney reporting language. So the goal of the inspection is to provide observations which may lead to the decrease of hazardous conditions associated with fireplaces and chimneys. It's an optional add-on inspection service, although the InterNACHI Home Inspection Standards of Practice and the COMSOP, the International Standards of Practice for Commercial Properties, do not require the inspector to perform a Phase 1 fireplace and chimney inspection. It may be offered in conjunction with a complete commercial or residential property inspection, or could be offered as a separate standalone inspection service. The inspector should advise his or her client that all fireplaces and chimneys should be inspected prior to the client's first use and not less than annually. So should be inspected when it's new and should be inspected once a year after that. As you can see, the chimney flashing, if it's on a masonry chimney, is usually visible. And what you need, the most common defect, just to let you guys know, the most common defect, so a lot of people see that side flashing and they think that that's step flashing. That is not. It's labeled as head flashing here. It's counter flashing. Oh, the head flashing is the one up slope. So yes, it's accurately labeled as counter flashing. And that little diagram on the upper right is the correct installation of this. So what normally happens in improper installation is that step flashing is installed when the roof is installed. The counter flashing is installed, maybe nailed in with some masonry nails, and then sealed with some kind of a sealant at the top. So sometimes it can be difficult to notice, but what you want to look for is what's called a kerf, K-E-R-F. You want to look for a kerf, which is a cut in that mortar joint and sometimes right into the side of the bricks to accommodate the top of that flashing being folded into the brick and then sealed over top of that. That's going to be your best water protection on step flashing for masonry chimneys. So that is a good view of it being installed correctly. So you can see the counter flashing installed in slots cut into the mortar joints and on the low side of the chimney. The apron flashing, which is basically a head wall condition, overlaps the shingle covering. So you can see the water diverting really nicely. That cricket has heavily applied roof sealant at the valley and ridge. That's a defect. If you see a roof to wall meetup of any kind and there's caulking applied like this, that's always a defect. Don't ever let caulking just be like all over the place. Call that out. This is going to be a good instance of like somebody thought that they were protecting this, and when they actually are creating a place for water to get trapped. This chimney lacks counter flashing and has improperly installed step flashing. Those are both defects. Okay, so they just sealed right over top without having any counter flashing. Now, to be fair, if it's stucco, a lot of cladding materials act as counter flashing, but it shouldn't be gobbed up with caulking like you see here. As you can see here, like we talked about before, the kickout flashing is missing at the area where the gutter end meets the chimney. And that is the opening right there on that wall. Water is going to run down and the step flashing is going to divert the water until finally it meets that end. And then that water is just going to pour in. Now, 100% of the water is not going to get in, but some of it will over and over and over again. And that's going to be a consistent issue. This chimney has a loose storm collar, right? That's a defect. The storm collar should not be loose. This chimney has a deteriorated rain cap, not a chimney cap, a rain cap. The chimney cap is below, and this isn't a very high resolution photo. It looks like there might be some issues there as well, but that deteriorated rain cap is a defect. That's an exterior fresh air intake for a prefabricated fireplace. Here is some combustible materials being pretty close to a fireplace. So combustible materials should be located at least 3 feet away from the fireplace opening. This photo shows a metal flue liner taken from below the damper. This shows a factory-built fireplace, a prefab with some type of vent component for circulating warm air around the unit and into the room. This shows a draft damper on the connector pipe from an oil-fired heating system into the masonry chimney. It's in very close proximity to combustible materials, including the dryer's plastic vent pipe and the plywood attached to the wall, which is a defect. This shows a smaller diameter flue connector pipe from the gas-fired hot water tank is properly located and entering the masonry chimney above the larger diameter connector pipe from the heating system. However, the smaller pipe is loose and detached from the inlet opening, which is a hazardous condition. So again, you're not required to, but if it looks like this, like what you're seeing there, look at the bigger one on the bottom. You can see how well sealed it is into that masonry chimney. That upper one just looks looser. So I don't know if it maybe needed to be repaired at some point in time. There's like a lot of tape around that joint. So I would just reach up and just touch it very carefully. I mean, if everything is fired correctly, then you might have hot air in there. So maybe put your hand nearby and see if it seems like it's flaming hot. If it's not, I would just give it a little push and see if it's jiggling loose, and I would call that out. So this photo shows an open damper and flue pipe from a brand new unused prefabricated fireplace. So that is what it should look like. Fireplaces, wood-burning stoves, and their chimneys must be inspected and cleaned every year. So again, when it's brand new, and after that, not less than once annually. Some damper doors are located at the top of the chimney stack. The damper operation should be accessible and in the same room as the fireplace. This is a small handle for operating the manual damper at a prefabricated fireplace. So even if it's tricky to locate, you're going to want to find if that manual damper is present, and it should be in the same room as the fireplace. The the flue connector pipe is in very close proximity to combustible materials. That is a fire hazard, right? And this is going to happen a lot in attic spaces because people just kind of pop a bunch of stuff up in their attic. And yes, that's a good point there, Kenneth. Um, so I'll mention that in just a second. But yeah, in the attic space, people just don't really pay close attention to some of those flue pipes, and they put all kinds of stuff in their attic without recognizing this is a very hot pipe passing through with hopefully some gap between the combustibles already. If you're adding new ones, you could potentially cause a house fire. And Kenneth brings up a good point. Testing hot exhaust pipes, just use the back of your hand. Don't grab it with your hand. That could end up very badly, which is a similar rule for electrical things. But yeah, just use common sense. If it's an exhaust flue pipe, there's a very good chance it's hot. So put your hand close by. You can touch it just gently, quickly, and if it doesn't seem like it's flaming hot, then yeah, you could push a little on. And again, that's only in an instance where I'm trying to see that something might be wrong. Like if there's a loose connection, if I want to push on that, I do want to give a little check, common sense check on how hot that pipe is before I go grabbing it. And me personally, I would probably never be grabbing it anyway because I'm not shaking it around with any level of force. I'm just trying to just give a gentle nudge and see if something is, completely loose. But thank you for that comment. So creosote buildup was observed on the rear wall of this fireplace. Inspection and cleaning by a certified chimney sweep are needed. Inspection and cleaning by a certified chimney sweep are needed. That's a pretty good level of creosote buildup. The mortar joints of this chimney are cracking into pieces, which is a defect. And again, are you required to poke and prod and pull at these things? Not necessarily. It's considered a visual only inspection, but I like to demonstrate things where I can. If I'm not going to knock the chimney over or something like that, I don't mind giving it a little prod, seeing if anything's coming loose. If there's any like obvious loose pieces that are about to fall off, this is a pretty compelling picture that would accompany some verbiage that says, hey, the mortar joints here are cracking and they're coming apart in pieces. This is a defect. I'd recommend a qualified chimney professional or a mason to get in there and do some repointing. This image shows the deteriorated flue lining, which is a pretty good size hazard. You can see on sort of the maybe 5 o'clock position, if you look down that liner, you can see some pieces broken loose from there. I would expect that if this is from a fireplace, that they would have found that piece in the fireplace at some point, maybe. This image shows a severely deteriorated flue lining, which is a defect. There's a giant hole there. And again, is it a material defect? Is it like an immediate, huge safety concern? I would say, yeah, it is. It's a pretty big safety concern. This is a deteriorated cap, the crown or the wash. That's a defect as well. You can see how badly cracked up that is. There's a piece that he's got in his hand there. Those gloves are not as much of a defect because they're not showing any fingers. The doors to wood stoves should operate as expected by the inspector and should close tightly with the latch. The rope around the door interior makes it for a tight seal. So you can see that metal mesh rope around the door. That should make a nice tight seal. So when that latch catches the hook on the other side of it, when you pull it closed or when you operate that handle, you should feel like it'll close to some amount, and then when you operate that handle, it'll pinch it closed just that much more. That's a really nice tight seal. Again, if it didn't have that, for any reason, if that was missing, that's something I would call out because for obvious reasons, you're going to get combustion gases coming into the house, um, and heat loss. And, again, the combustion gas is probably being the biggest safety concern, but that's not an operable chimney, a fireplace door, rather. Wood stove door, excuse me. This inspection shows a chimney pipe and chase in an unfinished attic space. So again, you can see the chase is that structure around that flue, and the flue is coming through. It looks like it's in contact with that, but that's probably a B vent, and the outside is not going to get too hot. Indications of an active roof leak can be seen in the chimney flashing area as observed in the unfinished attic space. So again, if you're not using infrared, infrared would help you to know, would help you to see that if the attic space is dark, if it's actively wet. And again, you would want to confirm with a moisture meter if it is actively wet. But this is a very obvious sign that if the chimney is not leaking now, it has been at some point. So again, if it's rained recently, moisture meter. If it hasn't rained recently, you can at least say, hey, look, this looks like a big problem. I would use the moisture meter. If it seems dry, but it's all stained up like this, it's possible that some repair has taken place. So that would kind of force me back out onto the roof. If I was on that roof and I saw that chimney and I said, this doesn't really look like there's a big issue. If I go in the attic and I see this, I'm going to go back out there. Because again, sometimes you have chimneys that have siding on them and things like that. It's that siding acts as a counter flashing, and it's a little bit difficult to see grave deficiencies in the flashing. But if you have an indicator like this is a beautiful opportunity to say, okay, I know for a fact that the flashing that's up there now is failing, or they had flashing up there at some point that was failing. That's an important thing to go take a look. So that's part of your roof inspection if you're doing it. This inspection photo shows a defect at the walls of the prefabricated fireplace, including large open cracks in the wall material. So that is obviously a defect. A gas-fired decorative fireplace unit, such as the one pictured, can be installed in a traditional fireplace, but only according to the manufacturer's recommendations and instructions. So like we said, this is a new gas-fired unit, and somebody had asked earlier about dampers. So if there is a damper here, there was originally, this is a sort of retrofit because it's a gas unit being installed in what was originally a solid fuel burning fireplace. If you look up in there, the damper either needs to be clipped or it is removed. A gas-fired fireplace cannot have a damper, a damper that's not clipped. And depending on your local jurisdiction, some jurisdictions may require that they're removed. I'm not aware of any, but I'm aware that the clip needs to be used to hold that damper in place if you have a gas-fired fireplace. Glass door enclosures should be inspected for damage, rust, attachment issues, cracked glass, and operation. So that's not super old looking, maybe 70s, maybe 80s. But I would probably, pull that and see if it rolls on the tracks well enough. If either of those doors isn't functioning, I would say something. So safe practices for fireplaces and wood stoves. More than 1/3 of Americans use fireplaces, wood stoves, and other fuel-fired appliances as primary heat sources in their homes. Unfortunately, many people are unaware of the fire risks when heating with wood and solid fuels. Heating fires account for 36% of residential home fires in rural areas every year. These fires are often due to creosote buildup in the chimneys and stovepipes. All home heating systems require regular maintenance to function safely and efficiently. That also applies specifically to outbuildings. And like I said earlier, my dad can attest to that specifically. He put a wood stove into his outdoor shed because it had a chimney stack. My brother, who's a firefighter, wasn't thrilled with this decision, and he was even less thrilled when his unit got called to fight the fire at my dad's burning shed up in Massachusetts. So the fireplace damper must be fully open before starting a fire and left open until the fire is completely out. The fireplaces should not be overloaded with firewood. Green or wet wood should never be used. Screens should be closed during the fireplace's operation to prevent sparks from flying out into the room. Glass door enclosures can be closed to reduce heat loss from the room into the chimney. Glass doors on a factory-built fireplace must be tested and listed for that particular fireplace. It can be dangerous to use the wrong set of glass doors. Depending on what it's being used for, those could fail based on their application. Wood stove, freestanding or insert style should never be installed in a factory-built fireplace system unless the insert has been tested and listed for such use. Annual chimney inspections and sweeping are recommended, if not required. Have your chimney or wood stove inspected and cleaned annually by a certified chimney specialist. Keep the area around the hearth clear of debris, decorations, and flammable materials. And again, that counts for above the chimney as well. 12 inches above the chimney, you don't want anything protruding out past 2 inches. Leave the glass doors open while burning a fire. Leaving the doors open ensures that the fire receives enough air to complete combustion and keeps creosote from building up in the chimney. Close the glass doors when the fire is out to prevent air from the chimney opening from getting into the room. Most glass fireplace doors have a metal mesh screen, which should be kept closed while the glass doors are open. That mesh screen helps keep embers from getting out of the fireplace area, obviously letting the air flow in. Always use a metal mesh screen with fireplaces that do not have a glass fireplace door. Install a stovepipe thermometer to help monitor the flue temperature. Keep air inlets on the wood stoves open and never restrict air supply to a fireplace. Otherwise, creosote might build up, which could lead to a chimney fire. Use fire-resistant materials on the walls around a wood stove. Never use flammable liquids to start a fire. Any accelerant at all, don't use them. There's all kinds of different fire starter methods you can use, little scraps of pine, and they make fire starters that are good for this application. Don't use an accelerant. Use only seasoned hardwood. Soft, damp wood accelerates creosote buildup, and pellet stoves burn only dry, seasoned wood pellets. Build small fires that burn completely and produce less smoke. Never burn cardboard boxes, trash, or other debris in your fireplace or wood stove. Do that outside in a trash can or something, unless you live in a very thickly settled area, in which case you're on your own. When building a fire, place logs at the rear of the fireplace on an adequate supporting grate. Never leave a fire in the fireplace unattended. Extinguish the fire before going to bed or leaving the house, and allow the ashes to cool before disposing of them. Place ashes in a tightly covered metal container and keep the ash container at least 10 feet away from your home and any other nearby buildings. Never empty the ash directly into a trash can. Hopefully that's obvious. Douse and saturate the ashes with water. Some people choose to have a water bucket outside to empty the ash into the water bucket, and that extinguishes any little embers and things like that. Stack firewood outdoors at least 30 feet away from your home. Keep the roof clear of leaves, pine needles, and other debris. Cover the chimney with a mesh screen spark arrestor. Extend all vent pipes at least 3 feet above the roof. Remove branches hanging above the chimney, flue, and vents. Install smoke alarms on every level of your home and inside and outside of each sleeping area. Test them monthly and change the batteries at least once a year. Consider installing the new long life smoke alarms. For foster care, you're required to have those 10-year ones in your house. Provide proper venting systems for all heating equipment. Fire safety is a personal responsibility. We'll answer that later. Fire extinguisher elements. You've got the neck ring collar, the inspection tag, which is an important one, the nameplate, the gauge, the pull pin, and the tamper seal. So a fire extinguisher is used to douse fire and prevent its spread. It's a small metal canister that contains compressed gas, usually nitrogen, that when activated propels a direct spray of flame retardant chemicals. Fire extinguishers are only effective if building occupants understand where and why they're used. So there's different classes of fire extinguishers, different types, and so we're going to go over real quick what those are. So A class is used against fires that result from ordinary combustibles such as wood and paper. B class is used against fires that result from combustible liquids like kerosene, gasoline, oil, and grease. Some of those otherwise known as accelerants. The Class C extinguisher is used against electrical fires. Those result from combustion of circuit breakers, wires, outlets, and other electrical devices and equipment. Extinguishers designed to handle this type of fire cannot use chemicals that are conductive, since conductive agents increase the risk of electrical shock to the operator. Class D extinguisher is used against fires that result from combustible metals such as sodium, potassium, titanium, and magnesium. These fires occur mostly in chemical laboratories and are rare in most other environments unless you use fireworks. K-class extinguisher is used against fires that consume vegetable oils and animal fats and are used for fires that generally happen in kitchens. So no fire extinguisher can be safely or effectively used for every type of fire. So some of them contain chemicals that are ineffective in certain situations and might even cause harm to the operator if they're not applied correctly. And so to prevent confusion, the extinguishers are classified by the type of chemical agents they contain. So a few of the most common extinguisher types are listed. The dry chemical, those are two types of fire extinguishers that use a dry chemical. It's called a multi-purpose dry chemical, uses ammonium phosphate as the extinguishing agent, which is effective on A, B, and C class fires. That chemical is corrosive and must be scrubbed from surfaces after use. These types of extinguishers are very common. They're found in schools, homes, hospitals, and offices. They're required for foster care in the state of North Carolina anyway. Sodium bicarbonate is used in extinguishers known as regular dry chemical, which are capable of handling B and C class fires. Those extinguishers are found in garages, kitchens, and labs. Sodium bicarbonate is easy to clean and it's non-toxic. Carbon dioxide extinguishers contain liquid CO2 that's expelled as a gas. They're very effective against B and C class fires. Unlike other chemicals, CO2 does not leave a harmful residue and it's environmentally friendly. It also poses very little danger to electronics and is effectively employed in laboratories, computer rooms, and other areas with very sensitive equipment. Water extinguishers are most suited for A-class fires. However, they cannot be used in B, C, or D-class fires. In B and D-class fires, the water will spread the flames. In a C-class fire, the water is conductive and poses a risk of electrical shock to the operator. However, the misting nozzle of a water mist extinguisher breaks up the stream of deionized water so that there's no conductive path back to the operator. Since the agent used as water, these types of extinguishers are very inexpensive and considered to be environmentally friendly. Wet chemical fire extinguishers. These devices are designed to combat K-class fires and are commonly used potassium acetate. They are appropriately employed in commercial kitchens and restaurants, especially around deep fryers. The chemical is emitted as a fine mist that does not cause grease to splash up onto the other surfaces, and they can also be used in Class A fires. InterNACHI inspectors should check that a portable fire extinguisher exists within 30-foot travel distance of a commercial type cooking equipment that uses cooking oil or animal fat. Check that a portable fire extinguisher is within 75 feet of travel on every floor. Check for the presence of portable extinguishers and determine that they are located in conspicuous and readily available locations, immediately available for use and not obscured from view. Confirm that access to extinguishers is not obstructed. Make sure that the hose, if so equipped, is intact and not obstructed. Make sure that pressure dial reads green or charged area. It should also be clear and readable. Check that the pull pin is securely fastened with the handle and held in place by the anti-tamper seal. Check for visible dents or cracks in the extinguisher's canister. Again, to the common sense side of home inspections, if you see something out of the ordinary, that's something that you're just going to want to take note of. Check that the extinguisher is in its proper location and mounted correctly. Check for modifications that might reduce the extinguisher's functionality, and make sure that the fire extinguisher has a label and that it's legible. You should not test a fire extinguisher. I sincerely hope that's obvious, but just to put it in writing, you should not test a fire extinguisher. And you do not determine the adequate number of fire extinguishers needed or their ratings. And you don't ignite or extinguish fires. We're putting that in there. Write it down. Don't light a fire. Don't extinguish a fire. Extinguisher testing and replacement. So the National Fire Protection Agency recommends that extinguishers be tested every 5 or 12 years, depending on the type. Again, you might have a more stringent regulation. A foster care in North Carolina, they have to be replaced every 2 years. The standard method of testing is conducted underwater, where the cylinders are subjected to pressures that exceed their ratings. Vessels that fail the test are condemned and destroyed, while the rest are reassembled and put back into service. So according to the NFPA, extinguishers should not be tested, but destroyed if any of the following conditions are present. Evidence of repair by soldering, welding, brazing, or the use of patching compounds. I would be very surprised because they're pretty affordable. So I would hope that I wouldn't see these things, but I suppose nothing should ever shock you as an inspector. If the cylinder threads are worn, corroded, broken, cracked, or nicked, if there's corrosion that has caused pitting, including pitting under a removable nameplate or name band assembly, the fire extinguisher has been burned in a fire. They usually destroy those. Calcium chloride type extinguisher agent was used in a stainless steel fire extinguisher. That's going to corrode that. The shell of copper or brass construction joined by soft solder or rivets. The depth of a dent exceeds 1/10 of the greatest dimension of the dent if not in a weld, or exceeds 1/4 inch if the dent includes a weld. Any local or general corrosion, cuts, gouges, dings that have moved more than 10% of the minimum cylinder wall thickness. Fire extinguisher has been used for any other purpose other than to extinguish a fire, like to break a window. When should a fire extinguisher be used? Small fires can be controlled through the use of household or commercial fire extinguishers. A firefighter would likely tell you, maybe don't waste your time, maybe just get out of there. But if it's a small fire, if it's a kitchen fire and you've got one handy, maybe use it. It can often completely douse a very small fire and prevent the need for professional assistance. Even if it can't be completely doused, a homeowner could potentially control a blaze with an extinguisher long enough for firefighters to arrive. Again, if something seems like it's getting out of control, think about your safety. It shouldn't be used if the operator is not sure if they have the proper type of extinguisher, which again, I would hope would go without saying. If you're not totally sure which type should be used, if you've got some kind of electrical fire or a grease fire and you're not sure, get out of there. What is on the label? You'll find essential information about the types of fires that the fire extinguisher can combat. Newer devices have pictures that correspond directly to the fire types listed above. Older models have letters for that same purpose. A numerical rating designates the extinguishing potential for that particular model, class A and B. Instructions for operation, and a tag indicates if and when an inspection of that extinguisher occurred. Do fire extinguishers expire? They do expire, and they do this for a few different reasons. One common way is that over time, the seal on the neck will weaken and allow compressed gas to escape. Extinguishers that have lost much of their pressure will not operate properly. Pressure within an extinguisher can be conveniently checked through a pressure gauge. ABC class extinguishers that are ammonium phosphate have a tendency to fail. Excuse me. Because of the solidification of the chemical in the canister base. Homeowners and inspectors can delay this process by periodically shaking the extinguisher. Expensive extinguishers that have expired, especially those designed for commercial use, can usually be refilled and resealed by the companies that specialize in this service. Inexpensive models that you get at Lowe's and things like that, you're just going to throw them away. Unfortunately, an expiration date cannot be fully trusted, and there's no foolproof way to know if an extinguisher is no longer functional. Due to the extremely destructive potential of fires and the relatively low cost of extinguishers, it's advisable to just replace or recharge questionable extinguishers. If you're in doubt, toss it out, get a new one. They're not that much money. In summary, extinguishers are classified based on their chemical ingredients, all of which have their own strengths and their own limitations. It's important to know which type of extinguisher combats what type of fire. Fire extinguishers are critical indoor components that must be maintained and inspected regularly. Fireplace fuel. So what can be burned in a fireplace, right? Fireplaces and wood stoves are designed to burn only one type of fuel. Used as all-purpose incinerators, these devices can pose the following hazards. Harmful vapors can vent into the living space. Even the most efficient fireplaces will vent directly into the living space when they're opened and closed for cleaning and refueling, exposing everyone in the house to potentially dangerous fumes. That is suboptimal, as you can imagine. And like we've kind of hammered a few different times, these are helpful tips, not just for your clients, but for yourself. If you have a wood burning stove or something like that, it's not an incinerator. It's not a trash disposal device. Don't throw plastics in there. Don't throw treated woods in there, right? Harmful vapors will vent to the outdoors. Most newer fireplaces and wood stoves do an excellent job of funneling smoke and fumes to the outdoors, but the problem doesn't end there. This pollution persists, contaminating household and environmental air, right? So you don't want to breathe it. Nobody else wants to breathe it. Don't burn crazy things. Burning inappropriate fuel, which might be a more politically correct way of saying crazy things. Burning inappropriate fuel can cause mechanical damage. Chimneys can become lined with residue from them, which may lead to a dangerous chimney fire. The fumes from certain items will quickly wear out sensitive components, such as catalytic combustors in wood stoves. So, there's one thing that you want to burn: dried cut firewood, right? An adequate fuel supply will consist of a mixture of hardwoods, such as maple and oak, and softwoods, such as fir and pine. Softwoods ignite quickly and they're useful in the early stages of a fire, while the hardwoods provide a longer lasting fire and are best used after preheating the chimney. Despite the different burning characteristics of hardwoods and softwoods, which can be attributed to differences in density, the heat energy released by burning wood is the same, regardless of the species and regardless of the hardness of the wood. To dry out wood, it should be stacked in an open area outdoors so that the sun can warm the pieces and the breeze can carry away the moisture. Poplar, spruce, and other softwoods generally dry quickly, as do wood that has been split into small pieces. Adequately seasoned wood has a moisture content of less than 20%, and you can check that using the following indicators. If the wood has darkened from a white or cream color, like a yellow, or to yellow or gray. There are cracks in or checks in the end grain. That happens when the wood dries out. It shrinks a little bit, and there you'll see some cracks in that end grain. A hollow sound is produced when two pieces of wood are banged together. Again, this is kind of in line with people knocking on the wall to find a stud. You know, it's highly subjective to user error, whether or not you think you're hearing something, but there is sort of like this hollow wood sound when you drop two dry pieces of wood and they knock each other, and it's a much more dull thump when something's very wet. The wood does not hiss while burning. That's dried wood, does not hiss while burning. When you put a wet piece of wood into a fire, the liquids inside start to become steam and they hiss as they're escaping. You can check moisture content with a moisture meter if you want to, as long as you're aware of what the relative humidity is and what a good percentage should be, which again, it should be less than 20%. Pallets, those are generally safe to burn in fireplaces, although those that are treated with the fumigant methyl bromide labeled with the initials MB are unsafe to burn. So if you have a pallet, you can look on the side of it, and there's usually a stamp. And if there's an MB, methyl bromide, if there's an MB stamp, then it was treated with a fumigant. There's a million other little stamps that might be on the side of a pallet. Just avoid any that have MB. Pallets may have been exposed to a variety of chemicals while they're in use, right? So if what was carried on that chemical, or sorry, what was carried on that pallet, let's say it was like a Home Depot pallet and it had a bunch of dangerous chemicals on it, you may not want to burn that either. But aside from those concerns, pallets produce a hot flame because they're usually pretty dry and their segments are pretty thin. So just careful to check for nails while you're cutting pallets. They might damage a saw blade. You almost also might wind up with nails in your ash, which should be disposed of far from roads and driveways. Fallen tree limbs can generally be collected and used for kindling wood, provided they've been given time to dry. And you can check that with the indicators that we talked about earlier. Wood collected from housing developments, if it's truly trash and not someone's property, including the housing contractors, using scavenged wood that has been cleared away for housing developments is good for burning. Try to obtain it before the non-lumber grade wood is pushed into massive piles and burned as means of disposal by the contractor. Fire logs are artificial logs that burn relatively clean and release less ash than their natural wood counterparts. And so what should be never placed in a fireplace? Well, since we said that dried cut firewood is the only thing that should be placed in a fireplace, a good answer might be everything else should not be placed there. But we'll just go through a couple for instances. Painted wood. Paint contains heavy metals such as lead, chromium, and titanium, which are used to make the different colors of the paint. So those metals, obviously lead, but all the others as well, could be toxic even in small quantities if they become vaporized and you inhale them. So if you're unsure if your paint has lead, you can consult with your InterNACHI inspector during your next scheduled inspection. Pressure treated wood. They stopped using arsenic to my knowledge, but nonetheless, it's still treated with dangerous chemicals. That wood is made resistant to fungus and insects through the addition of copper, chromate, and again, the older wood arsenic in a process known as CCA treatment. CCA treatment places about 27 grams of arsenic in every 12-foot 2x6, which is sufficient to kill about 250 adults, which is why it's illegal in the US to burn pressure treated wood, whether or not you knew that. Now, again, if you're burning a brand new piece of pressure treated lumber, it may not contain that arsenic, but who's burning new lumber? Who's buying pressure treated lumber to put in their fire? It's usually going to be, hey, we tore this deck down. Let's break up this wood and we'll save it. And we'll just burn it. Or a fence or any of these things. So if you don't know when the wood's from, there's a decent chance that that pressure treated lumber actually does have arsenic in it. And like they said, roughly 27 grams of arsenic in a 12-foot 2x6. That could kill 250 people. That's super toxic. Vaporized CCA wood, known as fly ash, is extremely toxic. In one case, as reported by the American Medical Association, a family was stricken with seizures, hair loss, debilitating headaches, blackouts, and nosebleeds from fly ash released when they unknowingly used CCA wood to burn in their fireplace. Even the family's houseplants and fish succumbed to the toxic fumes. Okay, so don't burn pressure treated lumber. Plywood, particle board, chipboard, OSB. If you know how those are made, you know that they're glued together. So when burned, these man-made woods release formaldehyde and possibly also hydrochloric acid or dioxin. Some states have outlawed the incineration of some of all of these artificial wood products. And again, it's all glued together, so you're just burning glue. Rotted, diseased, or moldy wood, that's not a good idea. It will not burn as long as other wood. It may produce bad smells when burned, and it could bring insects into the house. Not to mention, if it doesn't totally kill those spores, they could become airborne and you could breathe them. Damp wood that has a moisture content higher than 20% will burn inefficiently and contribute to a greater accumulation of creosote in the chimney, as well as air pollution. Allergenic plants, big red flag for me. I don't like urushiol. I don't exactly know how you say it. I know that poison ivy has it, and I hate it. This is the chemical that induces the typically minor allergic reaction, except for me, it's a major allergic reaction. When skin is exposed to poison ivy, poison sumac, or poison oak, it's far more dangerous when inhaled. It's not destroyed by fire because it's an oil. It can quickly cause life-threatening respiratory distress if any of these plants are burned. So be super careful. And to be honest, if you're cutting a tree outside, I always grew up thinking that the poison ivy was just the like green leaf with the three leaves, or whatever the heck it is. But come to find out, the vines that grow up around the tree that have those red hairs on them, that is the nastiest form of poison ivy that exists. And so if you're cutting down trees in your backyard and you think, I'll burn some of these inside, maybe don't if they have any kind of vines around them. And again, wait till they're dry. Dryer lint, it's often used as effectively as a fire starter, but lint can contain a wide array of dangerous chemicals that come from your clothes and fabric softener. That's a whole other conversation that Americans don't want to have. But there's a lot of dangerous chemicals on clothes and fabric softener. So if you're going to, you know that it's a fire risk because we talk about it when it comes to inspecting clothes dryers and other household appliances. So that if that's a fire risk, hey, that's probably a great fire starter. Well, it may have some dangerous chemicals in it that you don't want burning in your fireplace. So never burn household garbage. That contains a range of potentially hazardous chemicals and chemicals that react in unpredictable ways when burned together. Newspaper ink, plastics, aluminum foil, plastic baggies, and whatever else constitutes your trash, that can be a deadly little chemical cocktail. So if you think I'm going to save money by not having to throw so much trash to the trash service and I'll throw it in my fireplace or in my wood burning stove, just don't do it. Driftwood, which is counterintuitive, but wood found on the beach of an ocean or a salty lake will release salt when burned, which can quickly corrode any metal and etch the glass of a wood stove or fireplace. Catalytic converters are especially vulnerable to salt corrosion. In addition to potential chemicals, or sorry, in addition to potential damage to the stove or fireplace, the EPA claims that driftwood releases toxic chemicals when burned. So the EPA is saying don't do it for safety reasons because it can release toxic chemicals, at the least of which it could be really highly corrosive to the metals that make up those flues. So only use appropriate and approved fuel to burn in your fireplace or your wood stove, because certain items just never be burned. They can cause huge problems from minor irritation to an actual health threat to your family. So, like we said, if you're wondering what can be burned, there's really only just the one answer. So rather than thinking, can it be burned? Can't it be burned? There's this one small bucket of dried cut firewood, and then there's this other larger bucket of everything else in the world. If you have a fireplace or a wood stove, burn dried cut firewood in it and nothing else. I hope that we've sufficiently hammered that point home. So now we've got ventless and unvented combustion appliances. It's recommended that unvented combustion appliances not be installed within the conditioned spaces of a home. Unvented combustion appliances include unvented fireplaces, also known as ventless, vent-free, or ductless fireplaces. These gas, propane, or ethanol burning fireplaces have no vent, so they draw combustion air from the room they're in and release toxic combustion byproducts and moisture vapor back into the space in which they're located. Their use is banned in many states and municipalities. For aesthetic reasons, builders will sometimes install a ventless gas, propane, or ethanol burning fireplace in a home. The ventless appliances have real flames, providing the ambiance of a traditional fireplace with the convenience and cost savings for the builder because they don't need to install a chimney, right? Manufacturers report that they burn at nearly 100% efficiency, releasing fewer harmful gases into the home than other types of fireplaces. However, because they're ventless, any unburned combustion byproducts are released directly into the living space because there's no chimney to vent them out of the home. Also, because there's no air intake, many manufacturers recommend that a homeowners open a window during the operation of a fireplace. Also, there's no way to guarantee that the homeowners will follow this advice. And even if they do follow the advice, I wonder what the net result is of having your home so cold that you want a fire going and you have to open a window to operate the fireplace. A ventless fireplace that is burning efficiently will have a primarily blue flame. Defects such as plugged burner ports, a cracked burner, excessive gas input, impurities in the gas, or gas leaks somewhere in the unit can impact performance, reducing the efficiency of the burn and increasing the amount of combustion byproducts released. In addition to possible combustion byproducts, ventless combustion appliances also release significant amounts of water vapor into the air. Those products produce 1 gallon of water vapor for every 100,000 BTUs. So a 30,000 BTU appliance would release almost a gallon of water vapor for every 3 hours of operation, adding significantly to indoor humidity levels, which again makes the warmth feel more warm because that humidity is getting high. But if you're into building science at all, you know that humidity in an indoor living space is not ideal. Due to safety, health, and moisture concerns, some building scientists recommend that unvented appliances not be installed in homes. Energy Star version 3.0 permits their installation, but requires that an inspector test the appliance using a portable carbon monoxide monitoring device and verify that the ambient carbon monoxide level does not exceed 35 parts per million. The inspector should also confirm that the room size provides a minimum volume of combustion air for safe operating of the size of the building appliance installed as specified by the manufacturer and or the applicable building code. The National Fuel Gas Code prohibits the installation of ventless combustion heaters in bathrooms and bedrooms. Some ventless fireplaces come equipped with by the manufacturer with an oxygen detection sensor that will automatically shut down the appliance if oxygen levels in the room become too low. InterNACHI recommends that the homeowner install a CO detector in the room near the ventless fireplace in the same room. Because of safety concerns, several states and municipalities have just outright banned the use of ventless combustion appliances. So how to check unvented combustion appliances. Turn on or light the ventless combustion fireplace, which again, you're not required to do. but this is just how to check it for general purpose. Let the appliance operate for 10 minutes. Use a portable handheld CO monitor within the, sorry, use a portable handheld carbon monoxide monitor in the air within a few feet of the fireplace or appliance to test the ambient air nearby. So if the CO level is above 35 parts per million, the appliance fails the test and it must be serviced and retested or just replaced at the outset. Can the health hazards of an unvented heater be reduced? The most effective method to reduce the hazards is to discontinue use of unvented combustion appliance by switching to a vented gas or electric appliance. So can they be reduced? The best way to reduce it would be not to use it. But where the use of an unvented gas appliance is permitted, the following safety tips are recommended. Use only approved gas heaters with ODS pilots. Follow the operation and maintenance instructions very carefully. Clean the burner yearly or more often as required by the owner's manual. Do not use an oversized heater. The Gas Appliance Manufacturers Association recommends limiting the amount of pollutants by correctly sizing the appliance. So do a little research. If it's even allowed in your area and you want one, definitely do the research needed to size it properly. Do not operate for more than 4 hours at a time. Do not use unvented fuel-fired heaters in bedrooms, bathrooms, or confined spaces. Provide adequate ventilation as required in the homeowner's manual. An outside air source will likely be required. Discontinue the use of unvented combustion appliance if the pollutants cause health problems. Install a UL or IS listed carbon monoxide detector. Because low concentrations of carbon monoxide can cause health problems, the homeowner should install a detector advertised as a sensitive detector or one with a digital display. Ventilated fireplaces, they typically burn natural gas or propane and use a vent to bring outside combustion air directly into the firebox to support the fire. These fireplaces have tight-fitting glass doors across their face to prevent conditioned room air from being used as combustion air and then being expelled through the exhaust. Consuming room air for combustion may deplete oxygen levels in the home. Heat still radiates into the room. Exhaust gases can be expelled vertically up a chimney or horizontally out a sidewall. In addition to saving space and materials, taking away the need for a traditional chimney provides tremendous flexibility in where these fireplaces can be located. These closed combustion systems are much less likely to experience backdrafting, the hazardous situation in which exhaust gases are drawn into the home instead of being expelled to the outdoors, or contribute to the backdrafting in other combustible appliances such as water heaters or furnaces. So, unvented combustion appliances should not be installed within the conditioned space of a home. Their use is banned in many state and municipalities. Ventilated fireplaces help ensure that dangerous byproducts from burning fossil fuels cannot backdraft into the home. So it's banned in many states. It may not be banned in your state, but it may just be something. If you're in a place where it's allowed, just because it's allowed doesn't mean it's necessarily 100% safe. So it's something that if it happens to be allowed in your area, but you recognize an unvented appliance, an unvented combustion appliance in a conditioned space, you may just even list in your report some of the potential hazards for that without necessarily saying this needs to be changed or this needs to, be serviced immediately or any of these things. It may just say, here are some reasons why an unvented combustion appliance is not ideal in a conditioned space of the home. So, we are going to skip this video with Mike and Nick. So here are some things to look for. We've already talked pretty extensively about the chimney crown being cracked. It happens to be the #1 cause of water entry into the chimney chase. Look for a proper overhanging crown with a slope, an intact flue liner protruding. This says 1 to 2 inches above the crown. The correct figure, which I wish I could correct right now, but I can't. I'm going to do this. 4 inches. The flue liner should be protruding 4 inches above the crown. And there is not a caulked bond between that flue liner and the chimney crown. As promised earlier, I said I would go over the 3 levels or the 3 degrees of creosote buildup, depending on who you ask. Level 1 is just kind of a light powder. It's soot. It's just going to come off on your hand if you touch it. It can usually be removed just with a brush during a chimney sweep. That's kind of a normal maintenance thing for a chimney. There's going to be some level of creosote buildup, and you're just going to have to get it swept regularly. If you see that upper right picture, you can see that there are like these hard, shiny black flakes. That's going to be a level 2 creosote buildup. That requires usually more powerful tools to remove, and it's definitely going to need to be done by a professional. I would recommend a professional for any level of creosote buildup. I would recommend just if you have a chimney, to just have somebody who's going to service it, regularly. And then that third level is the most serious and hard to remove form of creosote. It's level 3. It's a thick, hard layer. It's like tar. It's really hard to remove, and it obscures the vent gases. So if that continues, worst case, that combusts or it completely obstructs the flow of harmful gases out of the home. And then that third picture, just another thing to look for. That's what that damper clip looks like. That's a prefabricated fireplace that is being retrofit into an existing fireplace. So it was a wood burning fireplace. They retrofitted, they put a prefab fireplace in there. And so the damper needed to be clipped in order to stay open so that the gas doesn't get trapped and come back into the home. So some people choose to remove that damper. At least you got to clip it. A couple helpful links for you guys. NACHI.org obviously is always a helpful link for everybody. I'm pretty sure you guys can click these if you want to. 2021 IRC Chapter 10 is for chimneys and fireplaces, some helpful guidelines there. And then the course on how to inspect fireplaces, stoves, and chimneys is that third link there. So, on time, that is my information. That's my company. And that's my email address if you guys need anything. And I think we're running up on time, but I'm happy to take some questions if we've got any.